Okay, we're back. I hope you can catch me. All right, everything looks good. 1 second. Where is the live? There it is, live. Okay, it's showing. Good, we're good. Okay, we can go. For God's sakes. I will be back shortly.
Solaria Binaria. Introduction. Since 1924, the theory of the expanding universe was first expounded. The phenomena of astronomy have been viewed increasingly as intensely energetic. The notion of an explosive universe has been abetted by the identification of novas, the discovery of immense energy trapped in the internal structure of an atom, and the detecting of radio noises from vast reaches of space, signaling events so extreme as the imploding of whole galaxies. What began as a whisper in scientific circles of the late 19th century has become, in late years, a shout. Yet, for reasons that can only be called ideological, that is, reflecting a constrained cognitive structure in the face of contradictory perceptions, scientific workers, on the whole, have not heard the shout, I'll say. At the same time as the space and nuclear sciences have had to confront a new set of facts. The near reaches of space have been surveyed and the body of the Earth searched more thoroughly. The results confirm that the wars of the universe have been disastrously enacted upon battlefields within the solar system. Without exception, the planetary material that has been closely inspected exhibits the effects of extreme forces unleashed upon it. Mars, Moon, Venus, Mercury are all heavily scarred. Jupiter and Saturn are in the throes of internal warfare. An asteroid belt that may be called Apollo represents a planet that exploded. Nor can we exclude from the common experience this scarred Earth. Consistent with the panorama of catastrophes, and additionally supplying a new dynamic form in cosmogony, there has been developed a body of knowledge and speculation surrounding the phenomena of stellar binary systems. The first binary star orbit was computed in 1822, but not until the past few years has sufficient information become available to speak about binary systematically. Since the first discovery, a large proportion of observed stars have come to be suspected as multiple star systems. Moreover, many cosmogonists speculate that the solar system itself was once a binary system, or at least is now a kind of fossil binary system, with Jupiter exhibiting star-like traits. It may be pointed out, for instance, that the distance between the principal bodies of the solar system is comparable with the distances between the separate components in many binary systems. Hence, it becomes logical that a cosmogony of the solar system should be modeled after the theory that it was and is a binary system, a Solaria Binaria, accepting and applying for the purpose of the model what is known and thought about the observed stellar binaries elsewhere. The explosive or catastrophic universe poses basic problems to chronology. The span of astronomical time have been increasing dramatically, even in the face of time-collapsing explosive events that reduce drastically the constraints upon time as a factor in change. Great stellar bodies exhibit rotations and motions that accomplish in hours phenomena that would, on a gradual timescale, be accorded millions or billions of years. It appears that one has to work with a paradox. Even as one studies a universe that changes over billions of years, one studies local events where changes are measured in microseconds. Consequence, which is the last hope of casualty, is often strained in the straddling of time. When the solar system comes to be viewed in the light of newly discovered universal transactions, the idea necessarily arises that it has developed under time-collapsing conditions, time measures, radiometric, geological, and biological, that have been painstakingly manufactured to give billions of years of longevity to the system, must submit to a review of their credibility. The need to generate a new chronometry is enhanced by current reassessments of legends and knowledge that ancient and prehistoric human beings possessed. The authors would not have ventured upon this reconstruction of the recent history of the solar system were it not for the fossilized voices whose shouts about their catastrophic early world and sky sound louder even today than the shout heard in contemporary science about the exploding universe. Those anthropologists and archaeologists and scholars of ancient humanity who believe that these shouts must have been mere whispers confront the same impasse ideologically as those scholars who overlook the larger meanings of explosive cosmogony today. What the ancients said and did not say about the world are to be taken into account. Both their concepts of time and their visions of events deserve consideration. I agree. This consideration and the others advanced before direct this monograph towards resolving the cosmogony of the solar system into a model of Solaria Binaria, the last stages of whose quick and violent quantivolution have been witnessed by human eyes. The model stands as plaintiff, confronting the model of uniformitarian evolution as adversary. Although a note on method is appended to the present work, it may be well to stress in the beginning that a prerequisite of scientifically is the ability to suspend judgment on a case being tried. This is especially painful when one is exert on the matter at issue. Even so, a scientist who cannot suspend judgment must be deemed as incompetent as the judge who cannot suspend judgment while hearing a case in a court of law. Even so, a scientist who cannot suspend judgment must be deemed as incompetent as the judge who cannot suspend judgment while hearing a case in a court of law. As so often happens, what interests the public coincides with what interests scientists, impelled by an intuition that is common to both the multitude of persons and the body of scholars. The human mind today is moving into an area where the action is, for perhaps no more exciting and important a set of problems is to be found anywhere in the realms of science and scholarship. System. Chapter 1. The Solar System as a Binary. Contrary to the hypothesis that the solar system was born as and has evolved as a single star system, it is here claimed that the solar system was and is a binary system. The binary system was formed when the primitive sun fissioned. Several planets were generated in the neck of the fissioning pair and co-revolved about the sun synchronously with the companion. See Figure 1, dumbbell motion of Solaria Binaria. The binary system rotates like a lopsided dumbbell as it moves through galactic space, the space origins about the planets, and the companion as they also orbit about the sun. To be precise, all bodies in the system orbit about its center of motion, and with the same period. The remaining planets were generated one or more at a time, in several episodes, as the companion became unstable because of a changing galactic environment, which we will discuss in Chapter 3. Jupiter can be taken to be the remnant binary partner. This quantivolutionary concept of a rapid developed solar binary system is consonant with observations of nearby star systems to 17 light years, or about 100 million times the Earth-Sun distance of 150 gigameters. There are 45 star systems consisting of 60 stars and 7 dark unseen bodies. Among these are many physical binary systems. 61% of the 60 nearest stars are components of a double or triple star system. Inasmuch as we cannot judge the organization of distant star systems, this statistic may or may not characterize the starry universe. Even within our sample of 60 nearby stars, the star density and binary frequency drop with increasing distance, a suspicious fact. Nothing that we know of the Sun is exclusively a property of a single star system, or would be surprising if found in a double star system. On the average, the principles in a physical binary system are separated by approximately 18 astronomical units. At one extreme, separations of up to 12,000 astronomical units are deduced. At the other, the stars orbit one another with their surfaces in contact. We see Solaria Binaria as a double star system, evolving from the close extreme to a system showing increasing separation of the principles with time. The typical visual binary system that has been analyzed contains principles whose separations, periods, total masses, and orbital shapes are not markedly different from the Sun, coupled with any one of the major planets of the present solar system. The present solar system differs from other visual binaries only when the luminosity and mass ratios of the principles are considered. The observed features of visual binary system are not an inconsistent final state for a physical binary system evolving in the manner that will be proposed here for Solaria Binaria. The present mass ratio between the Sun and its planets would seem inconsistent with observed binary systems, were it not for the fact that these latter are all visually observed and do not exclude the potential presence of binaries, where the minor principle is undetectable presently by any observation. Further, as we shall show in Chapter 4, the brightness of the Sun and its companion was markedly different in the binary phase than in the present system. The currently accepted cosmology of the Sun and the planets is dominated by concepts of gravitation, great stretches of time, and the stability of stellar and solar system motions. In this cosmogony, one looks backward and forward in time, confident that the world has been and will be found in place under known conditions. As one assumes the order of things in accord with a 300-year-old theory backed up by centuries of systematic observations. Occasionally, but nowadays with increasing frequency, new scientific discoveries are surprising or anomalous within the frame of the cosmogony. For instance, devastation has been widespread both on Earth and the other planets, whose surface details are visible, because theories had not predicted such instability. These disruptive events are insistently termed episodic and localized, and relegated to remote times. As will be shown, the prevailing cosmogony of science cannot cope with increasing numbers of surprising and anomalous observations. Sooner or later, an alternate cosmogonical theory is invited. The mutant evidence suggests that a cosmogony can be constructed which does not require a long time to evolve our habitable world, within which major readjustments of the planetary orbits and environments are possible, and which redefines the set of forces that bring about change. We begin with the theory that the solar system originated as a binary star system and has evolved to the present as such. In the course of elaborating this theory, we shall have to develop and use new tools of analysis, a general concept of electricity, new ways of viewing the origins of the atmosphere, lithosphere, and biosphere, an unusual form of legendary and historical inquiry, and revised measures of time for the purpose. Accepting the notion that the solar system may be presently at the end of a long binary trail leads to a theory that the sun is electrical. This fundamental idea is the topic of the next chapter. The solar system as electrical. The sun, as star, radiates energy into the space surrounding it. Stars can be conceived to have originated from electrical cavities in the structure of space. Space, to our mind, is an infinite electrical medium. It is electrical in that it is everywhere occupied by a charge, which, when it moves, assumes the character of electrons, that is, negative charge, C note B. The movement energizes, carries material into the cavities which become and are the stars. Such electrical cavities or stars are observed in the millions and infrared in the billions, in a fairly random distribution about the sun. They form a lagoon of stars that is called the galaxy, through which the sun moves in a manner and with consequences to be described in the next chapter. Materially, a star is an agglomeration of all that has accompanied the inflow of electrical charges from surrounding space. The cosmic dust, which astronomers see throughout the galaxy, is matter yet to be forced into stellar cavities, or matter that has been expelled after a star dies. This dust is detected in greatest amounts in the vicinity of the most highly active stars. Once in the cavity, the material cannot readily escape. It acquires increasing density because of electrical chemical binding and electrical accumulation. A cavity or star is increasingly charged, but during its lifetime, it cannot be more charged than the medium around it. The sun is highly charged, as some scientists have lately concluded. Bailey, 1960. The life history of any new star may normally proceed as its cavity acquires first matter, then charges continuously until its charge density reaches equilibrium with the surrounding medium, which is to say that the cavity has then been filled. Thereupon the star releases or mixes its material with the medium until it no longer possesses distinction as a body. This normal procedure is conditional upon the stars transacting with the space around it in a uniform manner. The majority of stars seem to transact quietly with their surrounding space. Whether they are small red stars or giant red stars, they end their existences as they lived, quietly passing their accumulated material into the medium of space, eventually becoming indistinguishable from the medium itself. However, the fact that the star is in motion within the galactic medium possesses an occasional problem. It may journey into regions of the galaxy which present it with greater or lesser electrical differences than it has been used to. Then quantivolution occurs. The star becomes one of the types to which astronomers pay the most attention: the variable stars, highly luminous stars, binary stars, the exploding stars. It was in one such adventure in space that the original super-sun lost its steady state, fissioned, and became Solaria Binaria. The system then consisted of a number of bodies acting first as small suns, with the primary partner as is to be related in Chapter 4. In recent times, according to the central theme of this book, this Solaria Binaria encountered a galactic region whose characteristics rendered the lesser stellar partner of the system unstable. In a series of quick changes, the binary was transformed into today's solar system. So basically, he is saying that all of the planets and the Jupiter, which was its binary star, came from the sun itself when it was a super sun. I get it. I thought that he was going to perhaps talk about the Saturn theory, but I don't think he's going to go there. We'll see. I mean, we're just reading a different take, you know. Bruce, 1944, sees the process of stellar evolution as a cyclic build-up of electrically charged atmosphere above the star. As we see it, galactic potentials will determine the nature of the surface presented to the outside observer. As the star journeys through galactic space, its surface nature changes in response to differences in galactic potential. A change in the local galactic environment can lead to an instability which results in catastrophic electrical redistribution of the whole stellar atmosphere, and sometimes of material found well beneath the star's surface layer. In short, the star becomes a nova. In this cosmogony, Bruce argues that binary stars form by division of an original stellar nucleus. When the star becomes a nova, the returning nova discharge transacting electrically with the normal outward flow of equal or greater than stellar wind off the star induces the outburst star to rotate. A possible reverse jet blast from the explosion might also cause the rotation to occur. Stars then should have a maximum rotation during the nova outburst. Fission of the star into a binary would then logically happen most frequently by rotational fission. Coble, 1938. Immediately after a nova outburst, close binary pairs should be found among the post-nova stars. The solar system is probably the descendant of a supersun, a body containing at least 11% more material than the existing sun, which became electrically unstable and underwent a nova explosion. When the supersun erupted as a nova, it divided into a close binary pair, whose primary became our present sun, and its companion was a body about 10% the size of the sun. See Littleton, 1953. Henceforth to be called Super Uranus. I did see Super Uranus. Enveloping the binary was a cloud of solar material constituting at least 1% of the sun's material. Also created in the fission were the seeds which grew into the so-called inner or terrestrial planets. Probably Mars, the Earth, Mercury, and one that will be called Apollo. Apollo's fate is discussed in Chapter 15. Turning our attention to the sun itself, we observe an opaque layer called the photosphere. This layer is regarded ordinarily as the sun's surface. Above the photosphere lies the transparent solar atmosphere, which is difficult to observe. First comes the equal or greater to the chromosphere, and then the corona. Perhaps the key to star behavior is the dysfunction between the photosphere and the chromosphere, which is examined and known by means of spectroscopy. That is, by observing and measuring its spectrum of equal or greater than radiation. The spectrum of the photosphere shows radiation produced when the atoms are equal to or greater than the ions and electrons of the photosphere collide, and therefore the spectrum reflects the state of atomic collisions there. The light is emitted during the collisions. It appears that the photosphere is a region of plasma and atoms where the motion of the material is chaotic, randomized. Collisions occur after short, mean, free paths of electrical accumulation. The electrical field is small. A high kinetic energy of collision is registered and the temperature of 7,000 degrees. Energy is transmitted with some, but not great amounts of conversion of energy into internal atomic structures, excitation. By contrast, the spectrum of the chromosphere represents the release of the eternal energy of exited atoms and ions. Light is emitted not so much at the moment of collision among atoms, but it is cast off by rapidly accelerating atoms, moving to and from collisions, that is, between rather than during collisions. The chromosphere is a region of directed, vertically moving electrons descending into the photosphere, and atoms and ions escaping into the corona and the solar wind, meaning free path is long. By contrast, the spectrum of the chromosphere represents the release of the internal energy of excited atoms and ions. Light is emitted not so much at the moment of collision among atoms, but it is cast off by rapidly accelerating atoms moving to and from collisions, that is, between rather than during collisions. The chromosphere is a region of directed vertically moving electrons descending into the photosphere, and atoms and ions escaping into the corona and the solar wind, mean the mean free path is long, not short. The electrical field is large, not small, as in the photosphere. The photosphere, thus, is a region where the transmission of energy is observed. The chromosphere is a region where the transmutation of energy is what is observed. The temperature measurements of the two regions are not helpful in understanding the dynamics, because in one case temperature is low, where short paths lead to frequent collisions, and in other temperature is high because of infrequent long path collisions. But as important is the contribution of each region to the electrical system of the sun. Cooler regions called sunspots. The average sunspot lasts less than a day. Bell, 1975. Viewed by telescope, the whole photosphere, except where sunspots obscure it, shows a granular appearance. These granules are bright patches, hot tufts of gas that live for only a few minutes. Jurgens, 1979. The photosphere and the behavior of the solar atmosphere, which lies above it, can best be explained using a model based upon the electrical processes. Bruce, 1944, and later Jurgens, 1972, and Crew, 1974, have shown that photosphere granules have the properties of a large number of parallel electrical arcs. Further, Jurgens maintains that highly energetic electrons are transmitted from the galaxy down through the solar atmosphere to the photosphere. As in the Earth's atmosphere, the gas density and pressure in the solar atmosphere decrease with height above the photosphere, where the atmospheric pressure falls to a value equal to 1% of the atmospheric pressure measured at the Earth's surface. Collisions between gas atoms can no longer dominate the exchange of energy between atoms. Instead, it is the electrical processes that govern the energy exchanges in the solar gas. We see this transition as the hot chromosphere. The bladed or spiculed structure of the chromosphere consists of jets of gas moving upwards at about 30 kilometers per second. These spicules rise some 5,000 to 20,000 kilometers above the photosphere. Bell, 1975. Instabilities in the arc discharges lead to a buildup of charged regions in the solar atmosphere. These eventually produce electrical breakdown. Sudden discharges occur, causing bright faculae and the temporary extinction of some photosphere arcs. The result is a sunspot. The upper atmosphere of the sun is apparently intensely hot corona. The gas atoms of the corona have been stripped of several electrons. By collisions with inflowing energetic cosmic electrons, the removed electrons are drawn towards the sun, so other ions can flow outwards into the corona, allowing the coronal ions to recede into the solar wind. The spectrum of the lower corona shows the atoms stripped of several electrons emitting light between collisions, and the emission from the energetic electrons during collision. Sudden explosive eruptions called flares occur above the solar surface. Energy in the form of light, atoms, and ions is accelerated away from the sun. The energy in a single flare could supply the Earth's population with electrical power for millions of years. A large flare releases in an instant about 1/40th of the continuous solar output. Flares start near sunspots with associated faculae and develop over hours. They move as if driven by an electrical potential difference between the sun's surface and the higher atmosphere, SATURN and Abashi. Once accelerated, the flare gases escape the sun and modify the solar wind significantly. The cause of flares is baffling to conventional theories, which underplay electrical forces and cosmic processes. Most flare models involve some kind of magnetic driver to blow the gases from the sun with great force. Babcock. The presence of magnetism implies an electrical source. As we shall show in Chapter 6, the sun once had an electrical connection to its companion, within which energy was released that created and sustained life within the binary system. Today's flares represent an undirected remnant of the inner companion arc of yesteryear. The solar wind consists of coronal gases which have been boiled away from the hot solar atmospheric discharges. It conducts the sun's electrical transaction with the galaxy. It is the sun's connection to the galaxy. The electron-deficient atoms, ions, by escaping from the solar system, increase the negative charge to the sun. This brings the sun towards the galactic neutral, and thus, in time, would end the sun's life as a star. It follows that in the past, when the sun was less negatively charged, more current flowed from the sun to the galaxy. Thus, the present flow of solar wind is less than the flow in ages past when the sun was more out of equilibrium than it is now. The solar wind varies with the ongoing evolution and quantivolution of the sun. In the past, the solar wind flow was very complex because we believed that the sun was a binary star and its companion, Super Uranus, was not in electrical equilibrium with it. The system eventually approached internal neutrality because a large solar wind, electrically driven, flowed directly between the two principles. Interesting. Conventionally view the formation of a solar-type star and planets from a cloud of gases and cosmic dust takes on the order of several hundreds of millions of years after accretion. An Earth-like planet supposedly takes another 1 or 2,000 million years, 1 to 2 gigayears or eons, to develop a stable lithosphere, which, when formed, allows the much slower evolution of a viable biosphere from the materials and energy available at the planetary surface apparent. To us, these processes seem too slow and rely too much on random occurrences to be viable. However, the processes forming stars and planets and leading to living things may proceed much more rapidly. Our cosmogony employs electrical cavities, charges, and forces to accomplish change. These procedure changes, which are much more powerful and are highly selective. Electrical force, as measurable by the repulsion between two electrons, compares with the apparent gravitational attraction of the same two electrons in the ratio of 10:36:1. Conventional models of cosmic processes employ almost exclusively the trivially force termed gravity to produce and govern the universe. Electricity is a greater sculptor of change because it operates more variably within a given cosmic setting. A simple lightning bolt can cause extensive surface damage, liberating megajoules of energy within a few meters of surviving observers. Only thousandths of a second are involved in the event, yet to an undisturbed geological surface may be the setting for a large number of biological mutations provoked by a radiation storm of cosmic origin. What gravity is supposed to accomplish in eons, electricity could quickly accomplish before the eyes of the earthly observer. driven by the powerful motivator electricity, quantum evolution becomes not only possible, but also essential. Furthermore, understanding of electricity's role provides a powerful new, unified explanation of the most observable phenomena. If the evidence cited in Chapter 1 has permitted us to proceed viewing the developing solar system as Solaria Binaria, and similarly if in Chapter 2 we end up viewing stars, and in particular the sun, as an electric phenomena, then we can hope to inquire about the timescale over which the solar binary developed. To be more specific, we may have a stellar binary which develops over a short interval through some of the most significant phases of the history of the solar system. To tackle the problem of chronology, we shall, as we have done before, look to the skies for the crucial clues. We must, in so doing, introduce a seemingly radical conception, one which we feel can be defended with the evidence to follow. We assert, in line with the past chapter, the stars take their properties less from the material which they contain and more from the electrical difference between the cavity which creates the star and the surrounding medium of electrified space. See space infracharge. Translated into more common astronomical language, the luminosity of the star depends upon its galactic environment rather than upon the amount of material which it contains. See behind, and to technical note B. The conventional notion that the more luminous the star, the more massive it is, was induced by Eddington from the analysis of a small sample of binary stars. As we interpret the same data, the more luminous the star, the more it transacts with its companion, and so the companion completes its orbit more rapidly. See technical note D. Unfortunately, Eddington's mass-luminosity relationship is well established in astronomical formalism. There is a problem inherent in Eddington's method of massing the binaries. He calls upon gravitational force and nothing else to bring about motion within the binary system. The problem is compounded when luminosities are introduced as a way to measure mass in non-binary systems. Luminosity can only be known where the distance to the star can be measured. Star distances are computed using the annual parallax produced by viewing the displacement as the Earth orbits the Sun of any nearby star against the background of very distant stars. The parallax measurement involves measuring the minute angle at the apex of an isosceles triangle, whose base is the diameter of the Earth's orbit about the Sun. Parallax angles are very small. The closest star, Alpha Centauri, is only displaced through 1.52 greater than arcseconds, or 1.52 arcseconds over the year. This parallax, the largest, was not measured until 1839, R.H. Baker. Parallaxes are difficult to measure, and they cannot be determined for stars further from Earth than 652 light-years. Such a small distance encompasses only 1,000th of the sphere of stars under close observation by astronomers. Thus, the majority of reported star distances and luminosities are derived by theory rather than measurement. Of the 21st magnitude stars, apparently brightest stars in the sky, only 5 are closer than 26 light-years. The next 5 take us to 84 light-years, the next 7 to 217 light-years, and the next 5 to the measurement limit. In this sample are 6 supergiant stars. The parallax of one of these stars is only an estimate. 2 of the others are at the extreme limit. The last 3 are between 171 and 192 light-years distant. None of the most luminous supergiant stars are in this sample. Thus, all luminosities given for such stars are estimates. Even where parallax is measured, the measurement is rarely precise. Uncertainties of 25% and larger are common, leading to luminosities which are most likely erroneous in the order of at least 56%, about half a magnitude unit. Near the measuring limit, the possible deviations grow immensely, often exceeding considerably the number measured. The famous Hertzsprung-Russell diagram, the Rosetta Stone of modern astronomy, plots stellar luminosities against surface temperatures, determined from the star's spectrum. Since the spectrum is often difficult to classify, placement of the star on a diagram is not always easy. R.H. Baker, to circumvent the difficulty, astronomers now rely upon color indices in place of spectrum classes. Such measurements are even more strongly theory-dependent than the former in terms of their applicability to stellar emissions. See Weiss, page 49. They are more quantitatively formulated, and therefore they lead to an unjustified sense of satisfaction with the computed result of the stellar condition. For our purpose, they offer no help. What we would say about the classification of stars is the following. In going from stars whose surface temperature appears to be high to those which appear cooler, there is a gradation of the lines present in the stellar spectra. The hotter stars show absorption produced by helium atoms. As we look at progressively cooler stars, the helium lines decline and abruptly hydrogen lines appear, increase in intensity and slowly decline. As the hydrogen declines, the lines of the metals and metal ions increase in intensity. Through the solar-type stars, they dominate in stars slightly cooler than the Sun, only to be surpassed in the coolest stars by band spectra produced by various simple molecules, notably hydrides and oxides. And some of the coolest star compounds of carbon are prominent. Although astronomers may continue to seek a more precise classification for stars, we are content to employ the traditional spectral types for the present study. Besides the Hertzsprung-Russell diagram, that is to classify the stars, astronomers have also divided the stars into populations according to their location within the galaxy. Some striking results were obtained. Number 1. The most luminous and apparently hottest stars are found within gaseous clouds containing cosmic dust. These stars are confined in clumps, a thin plate that forms the equator of the galaxy. Similar stars define the highly visible spiral arms seen in other galaxies. 2. Bright, cooler stars like Sirius are located near the equator of the galaxy, but are not confined to the galactic arms. 3. The disk of the galaxy is populated with moderately hot stars, with 5,000 to 8,000 K surface temperatures. These stars resemble the Sun and populate the arms, the spaces between the arms, and make up part of the stars that occupy the central core of the galaxy. These disk stars are the most numerous group of stars observed. I read before that red dwarfs were, but perhaps it's a different location in the galaxy. The disk of the galaxy is enveloped in an ovoid shell of red giant stars, whose spectra show fewer metals than stars of comparable type in the disk population. That these stars are mostly giant stars is usually explained by claiming that the smaller stars in the population are not likely seen because of distance from Earth. It is possible that the later are absent. Most of what is known about these stars is from the study of giant stars within star clusters, and intrinsically varying giant stars, where the star's luminosity varies, in some characteristics, way over an interval of days to months. 5. The galaxy itself is embedded in a halo of cooler stars. Most of what is known of the galactic halo is deduced from a study of a few nearby small stars and 120 globular star clusters, which surround the core of the galaxy. One of these globular clusters, Messier 13, in the constellation of Hercules, has been described as a celestial chrysanthemum. Baker, R.H., page 451. The number of stars in this cluster cannot be counted, but estimates around 500,000 are made. Averaging this number of stars over the volume of the cluster, not precisely known, it would seem as if the stars are about 2 light-years apart, much closer than the stars near the Sun. Some small halo stars are observed passing through the disk stars in the Sun's vicinity. Barnard star is an example. Yeah, those stars in them globular clusters, if they do have planets, which I'm sure they do, but life might not be very easy to come by there because of all the closeness of everything. Probably just get started and get wiped out, I would think anyway. Never know though. In summary, the most interactive stars and gas clouds form clumps, which are the galactic arms. Around the arms is a disk of less interactive stars. Enveloping the disk are variously shaped ovoids and halos, allegedly to be progressively more metal-deficient stars. It has been proposed that the stars of the different populations of the galaxy follow orbits about the galactic core, which are characteristic of the population. Supposedly, the arm stars have the most circular orbits. The disk stars follow slightly elliptical paths. The galactic plane, some are deemed to move inclined slightly to the galactic plane, like the asteroid orbits of the solar system. The halo stars move in strongly elliptical orbits with random inclinations to the galactic arms, like the comet orbits of the solar system.
We'll break
As
after
they
the
pass
end
through
of the
the sun's
chapter.
locality, the halo stars betray their presence by large annual displacements compared to the disk stars. All of the stars in the galaxy are in motion. Since there is no standard of rest, all we can detect is the motion of one star relative to another. Two streams of stars are observed moving past the sun parallel to the Milky Way, the arms of the galaxy. The two streams move oppositely at the relative speed of 40 kilometers a second. The outer stream moving towards Orion, the inner stream to Scutum. These motions apparently reflect differences in the motion of consecutive galactic arm segments in the galaxy. The stars in the sun's arm, we assume, move with the sun at 275 kilometers a second, towards the constellation of Lyra near Cygnus, which is a motion away from the stars of Puppis. Looking only at the net motion of stars close to the sun, we detect the drift of the sun within its arm of the galaxy. This analysis reveals a motion of 20 kilometers a second towards the constellation of Hercules, away from the constellation of Canis Major. Isn't that the biggest star that we've seen? It makes the sun look like the sun makes the earth look. Mihalis and Routley, page 103. Neither of the sun's motions is precise, but they should suffice for our purpose. The sun's motion within its arm carries it 4 astronomical units per year. It takes nearly 22,500 years for the sun to drift 1 light year from its present position. But when the galactic revolution motion is considered, the sun is moving up to 14 times as fast. Neither of the sun's motions is precise, but they should suffice for our purpose. The sun's motion within its arms carries it 4 astronomical units per year. It takes nearly 22,500 years for the sun to drift 1 light year from its present position. But when the galactic revolution motion is considered, the sun is moving up to 14 times as fast. In the extreme, only 1,107 years are required to displace the sun 1 light year. So in 10,000 years, the sun moves 9 light years, and in 1 million years, it travels about 904 light years. If our hypothesis is correct, and the stars derive their properties from the space in which they are embedded, then a look at the stars presently in the sun's wake will tell us how the sun appeared in ages past. Unfortunately, the path of the sun over the last million years, within which we believe Solaria Binaria developed and collapsed, is not wholly within measured space. Luminosity assumptions need to be made during the first 2/3 of the binary's lifetime. The sun's total motion now is directed away from a point within the constellation of Right Carina, the solar antipex, at 8.4 hours right ascension and declination minus 62 degrees. This antipex was determined by Stromberg using the radial velocities of globular star clusters. Just so you know the definition of antipex, the point of the celestial sphere from which the solar system is moving. In his sample, the sun's drift and the galaxy revolution combined to produce a net motion of 286 kilometers a second, away from the antipex. 4 star systems close to the sun, adjacent stars, are about 10.3 light years apart, each thus occupying a sphere containing 578 cubic light years of space. Allen, 1963, page 237. Given such a low star density, The rather large volume must be examined around and along the sun's wake to ensure that some stars are included. We have constructed, therefore, a cylinder 13 1/4 light years in radius about the sun's path. Moving for 10,000 years through this cylinder, the sun will encounter about 5,000 cubic light years of space. In such a volume, there would reside about 9 stars or star systems at the average local star density over the 65 light-year swath through space covered. By the Gliese star catalog, there are only 15 star systems. It appears that along the sun's path, the actual star density is only 27% of that expected. The sun entered the region included within the Gliese catalog about 74,000 years ago. Within that volume, our analytical sample of stars is reasonably complete. Beyond it, many of the stars located along the cylinder do not have published parallaxes, and so they cannot be located in time. They cannot be used in the analysis. The region of space which includes those stars, which now occupy the space once passed through by the sun on its galactic voyage, is represented on the star map by a cone centered on a solar antipax. The base of the cone in the present includes stars over 1/2 of the sky. As time progresses backward, the frustum of the cone projected upon the sky diminishes in area, figure 3. The frustum of the cone 500 years ago is a circle 76 degrees in radius, encompassing stars from Orion's belt across the south celestial pole to the Scorpion's tail. Moving back 20,000 years shortens the radius to 36 degrees, thereby including the region from the feet of the greater dog to the centaur's right foot. The area has only a 13.5 radius 60,000 years ago. It shrinks to less than a 3-degree circle after 300,000 years. Through recent time, the sun's trail is very close to a straight line projected towards the antipax. It is shown in figure 4, and the stars included are listed in table 1. The stars accompanying the space inhabited by the sun through the current era period of Solaria and during the time of the late quantivolutions, to be discussed in part 2 of this book, are in this sample. Here we find the nearest star system, the Alpha Centauri triple. The largest star is very similar to the sun. Figure 3, stars around the sun's apex. Oh, it's awful tiny. I'll try to blow it up, see what I can do. The sun's path, traced backwards through the stars of the galaxy, passes through a cylinder of space whose axis stretches from the center of the sun through the point on the celestial sphere with coordinates 8.4 hours of right ascension and minus 62 degrees of declination. The edge of this cylinder, chosen to have a radius of 13.25 light years, is represented for different eras by the series of circles converging onto the solar antipax. Its first companion is 23.5 astronomical units away, moving along an elliptical orbit, Menzel. This star is slightly cooler and fainter than the sun. The second companion is located almost 2 degrees away in the sky. It is over 550 times more distant than the separation of the closer pair. Frequent eruptions superpose bright emission lines on its otherwise faint Class M spectrum. It is a flare star. Its flaring might be associated with some intermittent transaction with the pair of distant companions. Unfortunately, the Alpha Centauri triple is the only occupant within the space transited by the sun during the series of quantivolutions preceding the historical period. It gives us no clue to an understanding of that space besides learning that solar-type stars can exist there. Figure 4, nearby stars in the solar wake. I'd like it to be a lot bigger. I'm interested to see it. It's just so tiny. I'm going to try to find it bigger. The sun's path through the space, now accompanied by the stars listed in Table 1. I've always wanted to know this, so this is interesting. This space represents the region traversed by the Sun while it quantivoluted from Solaria Binaria into the solar system we see today. The three remaining stars are all low transaction objects. This space we would suspect to hold a lower electric charge density than the space closer to the present. The closest of these three faint stars is located within the zone we believe was occupied by the Sun in the time before the eruptions began, which eventually broke up Solaria Binaria. That instability of the recent past may well have been created as the Sun passed between the lower and higher regions of the transaction, represented by the 6 nearby stars. The likelihood is that the Sun, late in the period of the Pangean stability, Table 6, was less luminous than it is today. And I've heard it burned hotter, so, I guess take your pick. Stars behind the Sun to 25,000 years ago: Alpha Centauri Triple, star main sequence components, a dwarf; G, K, and M stars, emission lines in the Type M spectrum; Gliese 191, MO main sequence dwarf star, 13 light-years away. The Alpha Centauri is a 4.3. Years in the Sun's wake: 4,860 for Alpha Centauri, 14,750 for Gliese 191. Gliese 440, a white dwarf star, class A, 16.1 light-years, 18,200 years in the Sun's wake. Gliese 293, a white dwarf star, 19.2 light-years, 21,700 years in the Sun's wake. Stars behind the Sun. Well, in the Sun's wake, that is behind the Sun. Stars behind the Sun. Okay, we're still going. Gliese 257, Gliese 341, Alpha Mencey, 25,000 to 75,000 years ago. Gliese 269, Gliese 333, Gliese 375. Boy, Gliese sure does discover a lot of stars. 294, 298, Alpha Chameleonis. That might be Chameleonis. These stars are 25 light-years apart. The Sun passes through space at their respective distances at the beginning and end of a 760-year interval. The gist of it, I do believe, is that he is stating that how hot the Sun burns is according to where it's at in space. That's what I think the point he's making here. Extending the Sun's line further into the past to the limit of the Gliese catalog, Table 2, we find no stars as luminous as the present Sun until we go back 54,000 years. Then along the path are positioned 3 stars that exceed the Sun in luminosity. The closest, an F3 subgiant, is 5 times more luminous. The second, primary star in a triple system, is only 1.44 times brighter. Its 2 companions are very faint. The last of the 3 brighter stars exceed the Sun's output 8-fold at the 75,000-year limit to Table 2. We reach the edge of the reasonably complete star sample. So far, there are no conflicts with our theory. Stars of different spectral classes are well separated in space. In fact, the cooler and hotter stars seem to be sorted. The Class M stars tend to lie above the Sun's route, while the Class F and G stars are below it. If our calculated course is correct, the Sun's past behavior as mirrored in the listed stars' present behavior would show significant variation in luminosity over the tens of thousands of years represented here. Noteworthy, there are no highly luminous stars thus far along the Sun's trace. Beyond 65 light-years, the magnitude limit of the available star catalogs containing measured parallaxes limits severely the completeness of the star sample. We can list no stars that are intrinsically fainter than today's Sun, Table 3. The catalog from which the sample was taken only stars whose visual magnitude exceeds 6.25, whereas the Gliese catalog includes known nearby stars above magnitude 18. Almost all of these stars show some distinguishing characteristic. The majority are binary, Another has nebulous spectrum lines. These stars are positioned about the solar antipex in Figure 5. All could reflect plausible conditions for the early stages of Solaria Binaria's period of Pangean stability, and possibly also for the earlier period of radiant genesis which followed the binary's creation.
Long chapter.
At the limit of our proposed time, about 1 million years before present, using the atlas of the selected areas, Finnerberg, we count about 39 stars brighter than magnitude 12.5 in a target zone 40 by 40 arc minutes. Adjacent to the sun's antipex, unfortunately, no distances are given for the stars in this atlas. Figure 5, the solar antipex. Map showing the brightest stars surrounding the solar antipex. The circles represent the described cylinder of space around the sun at the ages shown. I'm going to have to get a bigger one of those. I can't even see that. Maybe there's a way to make it bigger. I think there might be. The circles represented the described cylinder of space around the sun at the ages shown. The successive radii are centered upon a slowly displacing point representing the solar antipex. The displacement seen at this map scale occurs because the sun rapidly orbits about the center of the galaxy as it slowly moves through the arms of the galaxy. Its path, therefore, is curved rather than a straight line. Table 2, stars behind the sun over 75,000 years ago. Carinae, it's A2 binary, just numbers for the other ones. Limiting magnitude plus 6.5, the sample ends at the edge of measured space. Since our calculated solar target shows no stars, the deficiency of the present measurable sample is confirmed. Nevertheless, we see that the last listed star, 300,000 years BP along the sun's run, is a stereoscopic binary whose class B primary is orbited by a class K secondary. The system, not unlike our view of the early Solaria Binaria. In our analysis, more distant stars cannot be located in time along the sun's path. Yet, we can place, although uncertainly, several bright blue supergiant stars at locations surrounding the antipex in all directions, and at distances corresponding to times between 1/2 and 3 million years ago. Several of the stars are components in binary star systems. Within or on the periphery of this highly transactive region of space, the original supersun may have partitioned to give birth to Solaria Binaria. Parturition may have parturition to give birth to Solaria Binaria. Although proof is hardly forthcoming from this analysis, at least evidence disproving the hypothesis is absent. We are encouraged to retain the idea that the behavior of star systems depends, if only in part, upon the celestial charge level of the space through which they pass. It seems as if this electric charge is contained not only by material residing in the space, stars, atoms, and electrons, but also in part as a
The chapter that never ends. I knew this was a long one. I'm going to stop for a quick break to chat up a little bit. My friend Eric, bass player of my old band, was supposed to show up and chat with me a little bit. I don't know if he's having trouble or what's going on with him. I'm going to open up the mic. Are you guys there? Grouch, Val? I caught you by surprise, didn't I? Haha. Yes. They're going.
That fella.
Oh, wait. Oh, Greg's on. Hey,
Gotcha.
how are you?
Good self.
Not bad. Pretty good. Yeah, doing pretty good.
I'm still here too.
Oh, good.
There
Yeah.
you go.
Sorry about your
You know,
mother.
somebody-
Thank you.
Yeah. I know it's tough. You know, we lost Wall, and you know I haven't been feeling too good myself. No, I'm just kidding. My dad used to say that. But anyways, yeah, I try to keep it lighthearted because if you get into the depth and start stinking thinking, it can really make you sideways. You know what I mean?
That's correct.
You have to kind of
Yep.
take life and as it comes and with a grain of salt, really. And sometimes I have a tendency to get too serious. You know, my sons to remind me it's not that big of a deal, Dad. You know, so it's good because I remind them of a lot too.
I have your oldest to remind me it's not that serious.
Right, right, yeah, right. And he's man,
He's still my go-to when I'm taking things to heart.
I can't believe the amount of his friends that died. Just crazy.
I
I mean, he's
know.
lost probably 100 friends. I mean, high school chums. I mean, I know it's
Yeah.
exaggerating maybe a little bit, but at least 25. I mean, we played at one of their benefits, and you know, his friends from high school that era, late 70s. He was born in 78, so
Late 70s, early 80s. Yeah, we've
yeah,
lost a lot from our
yeah,
generation.
Generation X, isn't it? Isn't that Gen X?
Yeah.
I think so. Yeah.
Yeah.
They were just, I don't know, crazy. It seems to me.
Crazy,
Yeah, yeah,
depressed. A lot.
yeah, I know.
Yeah.
Yeah, and I don't know what's new, Andy. What's going on in the world? Everything going okay?
I think so. It's still spinning along. Hey?
Yeah. Well, we're not dead yet. Yeah, that's true.
No, why that's happening? We must be on a winner still.
I don't know
Yeah.
what happened to Eric. He told me he was going to show up and bring his girlfriend.
All right.
Yeah. I said, well, come on in and say
Oh.
hello. Can't hurt. I'm going to
Yeah, nice.
send him a text. See if he's still
Yeah.
about.
Eric, your old bandmate?
Yeah, you remember Eric, don't you?
Yeah,
Yeah.
of course I do.
Yeah. We used to play. We've been playing together since the first time I discovered him, and that was 1990, something like that.
Pygmy Bush babies.
Yeah.
Rock on.
Yes, that was later.
You better be careful, Val.
Yeah.
After you talk to Eric, you'll be on the garlic. Isn't that right?
Oh man, yeah, that stuff is so good. I mean, I don't
Yeah.
want to toot its horn, or I'm not making anything out of it, but that Allison, what's it called, Andy? Allison,
Yeah.
Med?
Yeah.
Allison.
Yeah,
Yeah.
kills anything. Somehow or other.
I'm
we
already
remain
on the-
alive.
Let me see. I'm gonna look up the definition of Allison. 'Cause
I'm
it's-
already on the garlic, the turmeric. I use natural things when I can.
Allison is a compound that may help ease inflammation, block free radicals. Well, I want it. What is it? Okay. Okay, Wikipedia here. Allison is defined. It's the chemical that. Let me see. Organ sulfur compound obtained from garlic, a species in the family of Allicea. When you first ingest it, something is created. That is Allison, and that's what makes garlic effective.
Mm-hmm.
Yeah. So you're getting how many cloves of?
6, the equivalent of the 600.
Yeah,
Cloves of
600 cloves. One pill is worth 600 cloves. It's a pungent oily
Yes.
liquid with antibacterial properties present in garlic.
That might be a bit overdoing it, but
No,
That's
I
what
tell
they
you what,
claim.
it's killed every cold that I thought I had coming on. I get
Yeah.
sniffles and then it's gone.
I typically just eat raw when I feel something coming on. I eat like 5 raw cloves,
Hmm.
and it'll typically knock it right out.
Oh, here it is. When fresh garlic is chopped or crushed, the enzyme allinase converts allicin into allicin, which is responsible for the aroma of fresh garlic. There it is, yeah. And all of
That's
its
what it
ingredients.
is.
Yeah.
That's what the 600 bit was. The 600 is the equivalent of the allicin that's in a clove of garlic. Yeah.
Yes, yes. It's the benefits are just
Now, Greg,
crazy.
but
It's
what about
anti-cancer for sure.
that though, Greg? As you're mainly an electric universe channel.
Hmm.
What about the grounding idea where you have to ground yourself?
Oh, that's another one. Andy turned me on to this. Now I've always known about grounding, and we do it. We call it earthing. We do it all the time.
Earthing?
Yeah, we do it all the time in the summer, but in the winter, I haven't been doing it. And this video that Andy turned me on to, first it was about this guy. I'm going to put the link in the description. Remember that guy that he was like going to die or something? Almost same as
Yep.
me. He had bacteria or something bad got into his liver instead of his lymph node. So I'm pretty darn lucky.
And it was from bad teeth.
And it was from bad teeth. He had two bad teeth, and he let it go longer than he should have. And
Yep.
he
Just back to that,
his
huh?
liver was 3/4 gone. He started earthing, and the damn thing healed.
Is yours just bacteria then?
I don't know. They told me it was cancerous, but I also read about that. They say that that stuff is one out of every four is a false positive. So I don't know. They scanned my whole body, and they couldn't find it. It's only in my
Yeah.
lymph node. And that's strange.
Cancer lights up a gallium dotate scan or a PET scan.
What's that?
Cancer typically lights up on a contrast scan using gallium.
What you said, you got to repeat it because you're breaking up. Say it again.
Oh, cancer scan typically goes up
No.
contrast material.
No, still didn't hear it. Say it.
Let's try that. Is that better?
Try it again.
Okay, could background noise might figure out. Cancer on a scan use contrast materials of gadolinium or gallium dotate 68, and they use a CAT scan, which is, well, it's called a PET scan, positive emission
yep.
tomography,
That's what it's called. Yep.
and it causes any cancerous cells to light up like a Christmas tree.
And they didn't find it anywhere but my neck.
Well,
So my neck
I
probably
would-
lit up like a Christmas tree.
I would err on the safe side if your neck lit up there in that lymph node and have that removed and go from there.
Yeah. The thought of having a lymph node removed doesn't exactly excite me. Don't they have another way?
Well, you could do radiation bomb maybe.
No.
Worse.
If you think about the sheer number of lymph nodes we have in our body, it's not quite as big of a deal as you would think.
Mhm.
I mean, we have our major hubs that work for fluid drainage, but if it's not a major hub node, which I don't think it is based on where you described it to be,
Mhm.
it's a minor hub node. Having it taken out will be of minimal risk and much larger benefit.
Now say that again. I'm
Okay, so from where you've described this lymph node to be,
sorry. Yes.
it doesn't sound like a major hub lymph node.
Mm-hmm.
Those are the ones you find at like the top of your arms, at your collarbone. They're in your legs. They run straight down the middle of your trunk.
What about the
What
ones
you've-
under your jaw? The one the doctor always feels.
Those are your carotid lymph nodes, and those will carry. There's a whole line of them underneath your jaw. But from where you've described the one you're talking about, it sounds like a minor hub node, which means it shouldn't affect the fluid movement, the movement of lymph. It just will move on to the next node to be dispersed.
I see.
The risk versus benefit at this point, if it lit up and says it's like the scans say it's cancerous and the biopsy says it's cancerous,
Yeah.
the risk versus benefit is negligible, in my opinion.
Yeah.
It's a smaller node It is not responsible for any major drainage areas, and lymphatic massage is so simple to do to move any drainage along if there does happen to be a buildup in that area, which would only happen typically, I would think, if you had like an infection in that area, and slept on that side at the same time. So like say your tooth flared up and you slept on that
That's
side
the
with your
side
hand.
I sleep on.
Okay. It would have to be both in conjunction though. Like my
What-
grandmother, when she had her double mastectomy with lymph nodes, they took, what did they take? 8 or 12 lymph nodes in her chest out. And
Yeah.
she ended up with a problem in her right arm, but not until 40 years later. And it was just fluid lymphatic drainage. It wouldn't drain. So we had to wrap it and elevate it and massage it and all that. But it was 40 years later.
Wow.
And it was a lot of nodes they took out. It wasn't just one. So if you have a problem with one, my sister-in-law had a problem with a salivary gland that was malignant, and they just took it out, and she's been fine ever since.
Mm.
And that's been over 20 years.
Well, we
So-
have over 300 lymph nodes in our body.
That's what I'm saying. Your body isn't going to miss just one.
No. It should
And at this point, if it's malignant, the risk versus reward.
What is the baseball thing doing on there? I don't understand that. How did that get
I'm
there?
not-
I'm sorry, I didn't mean to interrupt, but I'm looking on. Why do I have it on baseball? It should be on the slideshow. Why is that showing? You got to be kidding me! It's in the slideshow. I don't
Sometimes
know.
we get to click things in that don't belong.
Yeah, I don't know. Yes, sometimes I must have been doing something for the baseball channel. Okay. There you go. All right. So, anyways, that's good to know. So that I went through that whole process. Then, as soon as they remove this, I'm good to go for a while.
You should be great to go. There should be no problems, no long-lasting effects. Depending on which exact lymph node it is,
Right.
you might have a little localized numbness.
Yeah. Well, the third, I'm supposed to go get it taken out. So, I hope.
Okay.
I mean, it's only been 6 months. Boy, I tell you, if you get sick and you really need to be seen, I don't know. You're gonna have to take your chances with the ER. Because doing it through your doctor, it just takes forever.
Yeah, I'm going through that with my foot numbness right now.
Mm-hmm.
So I get it.
And
Greg, that
Yeah.
was Clint Ober. That was Clint Ober who
Yeah.
we were listening to.
I put the links in the chat. I can't put them in the description until I edit, so I'll do that for sure.
And the interesting part
They'll
about
be
it
there.
was you see a lot of people making claims about things, but he actually got the research done. They did measurements on voltages in people and all that as well.
Yeah.
So he actually went to work proving what he was talking about and the benefits to us of how now, since we have shoes with rubberized plastic soles and that on them,
That's
how
right.
we're not earthing.
That's right.
And
We're not
when we're
connected.
inside our house, inside our houses, we're not earthing. So unless you're sort of out on the bare dirt or grass, he actually mentioned being on grass,
Mhm.
you're really not going to earth. And,
Yeah.
like you think about it, most people would probably agree. Spending 20 minutes a day sitting or walking around on grass, not a lot would do that anymore.
Mhm. Right.
So he mentioned how, Val, he mentioned how it was advantageous to things like blood flow as well as your organs and that by
Mhm.
being back in equilibrium with Earth.
Yes.
That's about right, wasn't it?
And
yeah.
they explain the science behind it. It's electrons.
Yes.
And this negative electricity. And that one video I did, Andy, that we did. You helped me with the research on it. The one that was
Yeah,
supposed
on
to
the
be-
salts.
Yes, on the salts.
On the salts, yes.
Right. I'll spit it out.
And then there was the other one you did with the fella who wrote the book about the effects of X-rays over time too.
Oh, you're talking
You know,
about
that was going.
that's the something rainbow?
Yes,
Yeah,
yes,
the electric rainbow. Everything
yeah.
is
That's
electric. Hey guys, chat. That's Eric. I'm going to talk to him. You guys chat it up. I'll be back.
all right then. So what do
So
you?
I was actually just looking at how many lymph nodes sit exactly where, like in the area of not, and there's 10. I don't think one is going to be.
Being this one?
Oh, it's
Yeah,
difficult to explain Discord to people too, especially in our age group.
yeah. But what people don't realise too is Discord isn't like you can do what you want on it. They do monitor it.
Right.
You read the terms and conditions. You read the terms and conditions of Discord. It is monitored.
Yeah.
So yeah. So it's not like open free. You know, say what you want, do what you want type thing.
Right.
Yeah.
Absolutely.
So where are you, Greg? Well, we're
I
just talking about
I
Discord.
quick looked up how many lymph nodes are under the jaw, like from right in front of the ear all the way under the jaw.
Mm-hmm.
There's 10 on each side.
10 on each
There's
side.
yeah, there's 10 on the left, 10 on the right.
Mm-hmm.
There's 20 just that run along your jawline from the front of your ear to the other front of the ear. So there's 20 there.
20.
You won't miss one.
Well, I
Well,
suppose that's true.
he might he might walk crooked or hold his head on an angle after that. Losing that one, he'll be out of balance.
Yeah, I don't want to hear that. I'm out of balance enough as it is.
Well, you'll be back in balance.
Yeah, maybe that's true. Yeah, maybe I will.
Yeah. So anyway, so what other exciting things have you got planned for us today, Greg?
Well, I'm really into Solaria Binaria because he talks about things you never hear of, like what he was just talking about, where the sun has been. Like if the sun, if you look back where the sun was, say 50,000 years ago, and there's a red giant there, chances are that the sun was that when it was there, or some, that's the gist I'm picking up from him. No, I don't know,
Yeah.
but it's all about electricity, just like humans, just like us. Everything
And it
is
was
electric.
changed.
And if everything is electric, that means that we could be treated for crap like what I got electrically. And you know, there was a guy named Rife who cured. Did you hear the story about him, Royal Rife?
The
Dr.
right
Rife.
machine.
Yes, he
Yeah.
cured 30 patients with stage 4 cancer. And they suppressed it. I heard he went to a mental home. I don't know. But his machine is still sold today. And they said that the hertz, the sound can kill it, is 100,000 to 300,000 hertz kills cancer. And he proved it. And if he did it to stage 4 people, I mean, what else does he have to do to prove it? But they don't really want a cure in the medical industry. That was created by the robber barons, you know,
Yep.
Well, I have a question
not
about
doctors. Yeah, go ahead.
Hertz a measurement of sound.
Yes, but sound
I
is an
give-
electric
Yes.
signal.
But given where your specific issue is located, I have to wonder what kind of damage it would do to the ear canal, the inner ear, the crystals, the eardrum.
Well, you know,
Like,
I know what you're going with that. I don't think you put headphones on. I think he blasts the body with it in an ultrasound kind of way.
Okay, so
He
it's
created
more like
his own
that.
machine, so the guy had to be a genius.
Okay, so more like a massive immune system booster.
I'm going to look it up right
Yeah.
now. Yeah,
And you wouldn't
go ahead, guys.
hear, you know, like
No, that's
You
way.
wouldn't hear it. Though.
That pitch is not audible to the human ear.
That's right. So the chances of it damaging the ear as well are probably very, very slim.
Well, I'm thinking mostly about the crystals. They use things with megahertz, terahertz, what have you, to blast up urea crystals for those with kidney stones.
Yeah.
And what would it do to the actual crystals inside your ear that keep you in balance? And when they go out of their places, will give you vertigo. What would it do to the crystals? More even than the eardrum, but the little crystals in your ear. What would it do to those if it was that close?
That was the original.
Like,
yeah.
I do have
And
to ask that.
yeah, and the point is, it may affect some people more than others.
Yes.
So that's probably one of the bigger things. Yeah.
Well, I bet you they charge a pretty penny for it.
Oh, there's all kinds of new treatments, and there are 2 hospitals in Michigan that do a targeted proton radiation therapy that is extremely, extremely beneficial and has a very high cure rate. But the beds, one of them is Royal Oak Beaumont, the other one is McLaren Flint. And but the beds are always taken up by pediatric brain cancer patients. So to even get to that point is near impossible as an adult.
You know, it's like
Which-
with that guy. Go ahead, I'm sorry.
I'm not saying is wrong, but I'm saying we need to build more of these machines that actually go on a proton level and eradicate cancer cells. Instead of all these chemo clinics and radiation therapy clinics and yada yada yada, we need to build more beds to treat cancer patients with something that actually destroys the cancer cell at a molecular level.
The current treatment is
Proton.
barbaric, if you ask me. I mean, we're still doing
Chemotherapy-
chemo and radiation. I mean, they've been doing that since the 60s. It kills
It's getting
everything. You
better.
ever see somebody after they've been through it?
Yeah, unfortunately.
I mean, how many people actually die of cancer and not the side effects of the cure? That's what I mean. So I don't think the AMA doesn't seem to be real. I mean, yeah, they'll have good treatments in that way as long as it costs a lot of money. You know, if
Well-
you find a cheap cure, they destroy it because cancer's their best friend. They're into treating sick. They're not into
I was talking to my
healing you.
neighbor.
They have never found
My-
one cure.
I was talking to my neighbor earlier about this, especially here in the USA. Problems that we have are our food makes us sick, our water makes us sick,
Yes.
our air makes us sick.
Yeah.
This is the best business model that you could ever come up with. The same regulation agency that approves all of these things to be marketed and sold to humans for consumption is the same agency that markets and approves the treatments, if you will, that are typically also poisons. And so it's a cycling of customers because we don't have raw real food or access to it. Having organic food, it's a myth. Organic just means that they didn't directly spray those crops. Instead, they sprayed the road next to it on a windy day where the spray and pesticides carried over onto the organic crops.
Mm-hmm.
Everything is genetically modified. Our water is chlorinated. It has fluoride added to it. It has all of these things added to it.
Yeah. The average American diet is deadly.
Yeah, and then what we breathe, what comes down in rain because of how we pollute. Everything that we consume is detrimental to our health.
Seems so.
And everything they give us has some sort of side effect too.
Yeah, for sure. That's right.
Aside from very basic like penicillins, and people who are allergic obviously have a major side effect. Your very, very basic quote unquote natural, like if you could get a natural penicillin, that would be beneficial.
And that is where we get Allison. That's one of the supplements I take.
Allison is a great
Yeah.
compound.
Vitamin C.
Um,
Allison, vitamin C. I also take quercetin, turmeric,
uh-huh.
curcumin,
Yep.
uh, graviola. That's a little tree that grows in South America. They found out that the fruit and the root of the tree cures some cancers. So that's why I got that. Graviola and lion's mane. Have you ever heard of lion's mane? I learned that
Well,
from
lion's
Ramon.
mushroom,
Yeah.
the mushroom.
Yeah, it's anti-cancer. And plus
Okay.
it's good for your brain. It prevents dementia, which
Right.
I've had
And that's
for
always,
a decade now, at least.
I wouldn't say you have dementia.
No.
Yeah, selective memory.
Yeah,
Sometimes.
yeah. And
You're
vitamin
getting the
D3 and K2. Yeah, that's what I'm on. I'm strung out on it, man.
Well, Greg, you just about rattled.
Oh, wait a minute. One
yeah,
more. Oregano oil. Oil of oregano. Yeah.
that's a good one. That's another good one.
Yeah,
A
I'm going
lot
to
of
take one
these
right now. Good.
are good. Um,
Get.
in moderation, knowing exactly how much you need to take before it becomes toxic to your body, because even water at its most basic level can become toxic. So,
Yeah.
like your vitamin
That's,
D3 stores in your fat cells, it's not excreted through urine, but a dramatic weight loss can cause a lot of vitamin D3 to the point of toxicity to be dumped into your body. And I take D3, so I have to watch it too.
oh, really? I didn't know that. I'm going to have to be careful. I take one a day. That's what I do.
Same with K2, which is
Yeah.
potassium.
D3 and
I take
K2.
also.
My friend Eric schooled me on D3. If you take
D3 is
D3, it will harden your arteries unless you take it with K2. So you have to take them
that I'm
together.
not aware of.
Yeah,
Although
yeah.
I will say that I
K2 is for your
have,
bones and arteries and stuff.
yes, I've been prescribed both of those actually because mine are so low.
Hmm.
Um, and it probably has a lot to do with my diet or lack thereof. My protein intake is crap. So
Hmm.
A lot too can be down to your sleep patterns as well.
my sleep patterns are horrible. I'm an insomniac.
Oh, you should see mine. They're just atrocious.
Well,
Oh, and I sell
well,
Yep.
supplements.
you
Yeah,
well you should try grounding your bed.
I'm going to.
There you go.
I am going to do that tomorrow. I'm going to Home Depot. I'm going to buy that little iron and some wire and some of that metal tape and do just like that guy did and build it.
Yep.
It's no big deal. All you got to do is just lay on one part of it and you're grounded no matter how much electricity is around you. Because you could be sitting in your bed where nothing is, but there's shit zapping through you.
I have my
Collecting.
organ pyramid.
You know, that's, what's that, 5? What's that called? G5? G5.
Not sure.
Yeah,
I
it's,
have my organ pyramids where
Oh
my
yeah.
electric hubs are. Um,
you have your
try and zap that.
pyramids.
The orgonite pyramids, yeah.
Oh, I have one, but that's so little. Does it really do anything? I don't know.
I'm not sure that mine's doing as much as it needs or should be doing.
Yeah.
I have a Himalayan salt lamp next to my bed, for
There-
breathing.
There's something about the triangle, you know, the pyramid shape, that even if you just have one and get inside of it, it's supposed to be beneficial,
Hmm.
healthy.
Oh, my husband calls me a hoodoo, voodoo, hippie dippy
Uh,
for all
uh,
of this stuff.
yeah, that's okay. There's nothing wrong with that. I think that's cool. It means you're a
It's
deep thinker. You got a good imagination. You need one.
it's interesting, and I believe, like you believe, and like you preach on your channel, that everything has an energy.
Yeah, for sure.
That's cool.
Spread disease germs destroyed
And it's
by
about keeping the
rays, claim scientists.
and it's about keeping the energies in balance. That's
Yes.
the key. Yes.
Yes, and if holding my muggle stone helps me balance my energy, so be it.
Yeah.
Whether it's placebo effect from rubbing the smooth polished stone or not, leave me alone. Let me rub my muggle stone and carry my amethyst or whatever.
Hey, I love
stone it is.
crystals, man. I wear
I love
one. I wear amethyst.
I have crystals. I have so many crystals. It's disgusting.
They say crystals are alive, and humans are actually liquid crystals. I mean,
Yeah.
in essence, I can't spell. There, okay.
I have mountains of crystals. They're everywhere. Oh my goodness.
Yeah, they're known for healing properties. Amethyst.
Yes, they are.
Mm-hmm.
Yes, they are.
Yeah, I wear
I'm not a
mine.
doctor,
I
but if they
have one
help
of
me,
them little circles.
yep, yep, you have a sphere.
Yes.
I
Yeah.
have spheres and towers and
And I
rods.
wear a cuneiform ring. You know,
Mm, yep.
it just lets people know that I'm really cool.
Gangster.
Yeah.
Absolute.
Is he a gangster? Yeah.
You've only got one ring, so you're pretty well down the pecking order.
Yeah, I used to wear another one, but I pawned it for $50
Yeah, well,
for a hit of smack. No.
Oh, please.
Those, once people go there, they're done. It's over.
They never come back fully from
They
that
never,
one.
I mean, it rules their life. They'll even steal from their own mother or father just to get high, and then
Tell me about
they
it.
get disowned.
I got across the street from me, and oh,
It all starts with the doctor prescribing you a pain pill for your hip or your knee, right? And then, hey, I kind of like the way these things make me feel, because when I went through it,
not
from
two.
my
These
knee,
two were
and
these from
I was eating, man, as many pills as I could get my hands on, 60 a day, sometimes.
Vicodin specifically is
Yeah.
bad for being a gateway to
And I was
smack.
sitting there watching my kids play, and I thought, I am one selfish son of a bitch. Those kids need me. And if something happened to me, I wouldn't be here for them. I need to quit
Yeah.
this shit. So I went to the doctor. I said, I'm taking Vicodin. I need to get off, and I need something to get me through the withdrawals. And he said,
Hmm.
how many do you take a day? And I said, on average? He said, yeah. I said, 20. And he looked at me. He goes, come on. I'm like, I've taken 50 before. Because it goes away in 20 minutes. You know. You
Well,
want
especially when
and then I found out I was killing my liver. So he got me on
Oh,
Suboxone. I was on them for a while, and now it's gone, and I don't even want to think about ever taking anything again like that. It could have
no,
killed me.
no, a little THC every once in a while never
Oh
hurt
yeah,
anyone.
there's nothing wrong with smoking weed. It's actually healthy.
Yeah, don't
Yeah.
panic. It's organic.
Yeah, there's nothing wrong with marijuana. I've never thought so. You know,
No,
I've been
and that's
smoking
kind
it
of.
since I was 15. There's nothing wrong with me.
I don't think it's.
I'm just kidding.
I don't think that's a gate drug to anything. I think that you're 100% right about prescription drugs being the gateway, and or people that are just naturally born with those addictive, lack of self-control personalities.
We're supposed to be born with 7 vices, and then we're supposed to turn them into 7 virtues.
No. 7 vices.
And 7 chakras.
I have 7 chakras.
7
That I know.
planets you can see, including the moon.
Yeah.
Everything is 7 and 12. 7 and 12.
Yeah. 7 vices that I was born with.
That's what they say in astrology.
I'm trying to think of
Astrotheology. It was shortened
like
to astrology, and that cheapens it. That makes people think it's newspaper shit. It's
yeah.
not. It's not.
Well, I'm a cigarette smoker and I drink Pepsi.
Mm-hmm. Pepsi's like, what is it? What did you call it, Andy? Battery acid? You might as well be drinking
Yeah.
battery acid.
Horrible.
Yeah.
You know what? You are. What's that thing in us that when
It's
it
the
goes,
sugars.
we're diabetic?
It's the sugars.
Pancreas.
It's the sugars.
Pancreas can't
It's-
handle it.
Yeah, it's high fructose corn syrup and it's horrible
Yes.
for you. And it's probably the hardest addiction I've ever had to kick.
Oh, and it
And
was
I
for me too. I love
I kicked
Pepsi.
it twice and I go back. And
Yeah.
it's horrible.
But
Um,
I'm up for a good root beer or orange too. You know, it doesn't have to be cola.
The
A good
original
root-
Coca-Cola was good.
What was that?
Yeah,
The
I
original
bet.
Coca-Cola was good because you'd have a couple of aspirins with it and stay awake all night.
Yeah, I bet it was good with all the cocaine in it.
Yeah, yeah. When it first came out, that's right. The
Hmm.
base ingredient was cocaine. That's why they call
Hmm.
it Coca-Cola.
Hmm.
Yeah, I'm down for a good root beer.
And Pepsi, because you're all pepped up.
Yeah, most definitely. I'm
Yeah, I
sure it
was.
contributes to anxiety.
Well, they have those
Yes, for sure.
so-called energy drinks. They have the
Yes.
so-called energy drinks
Yeah.
now,
Yeah.
and they're just a mass of caffeine and sugar.
Oh, and all
When you
kinds
think
of
about
other
it,
Eric, are
unregulated
you
they're
coming?
yeah,
Do you need help?
yeah. So,
energy drinks are awful, awful, awful.
mm, mm,
Those I can say I did go through a
Not going to be
phase when
on
I was
much longer.
in the bars and drinking. I haven't drank in almost 13 years, so
well, see,
I don't
yeah,
like it anymore. It was never really a vice of mine, I guess. It
just
was
part
more
of
of an I'm stuck with a bunch of drunk people and I don't like drunk people, so I'm gonna drink so I can tolerate them.
mm,
And it was
yeah,
only nights when I worked, and that was that. I didn't drink heavily. The problem was I worked in bars for over 12 years. So,
I just hold on just a second. Here's Eric. He's having some troubles, I think. Hold on. Eric,
distorts the sleep system.
are you there? What happened?
trying to think of any other vices I might have been born with. Maybe being contrary.
Guys, chat while I
Contrary.
talk to Eric.
Stubborn.
Chat it up. Be back.
Yeah, no worries. Yeah,
I've been
yeah. Look,
contrary.
we all have our vices. I suppose it depends on how long you stick with each one.
I was contrary and um argumentative. Now
Yeah.
I consider myself to be well researched, well educated, while still being contrary at times.
Hmm.
Because I don't always agree with everyone and I have very strong convictions. Once I've
Yeah,
searched and formulated a belief, it's very, very difficult to switch.
yeah. But you can also find you don't have to argue with them. You just go, oh well, you believe what you want to believe. I'm happy. You get what I mean. There's nothing
Definitely.
wrong with believing. Yeah, yeah. Because people get fixed in their ways. And it doesn't matter what they believe. They're not going to change it until there's some big reason why.
Well, and that I've gotten pretty good at, except for my own, like my close family.
Yeah, yeah.
Walking away from anyone who is um a toxic energy vampire, um anyone
Like
who
saying
is
oxygen thieves.
unenlightened and doesn't want to be
Yeah,
unaware. Like there's the definition of woke in pop culture, and then there's our definition of woke, and they're two very different things.
Okay, guys, I got the lowdown on Eric.
Mm.
He's having some technical problems getting on Discord. He did before the last time when he was on. Remember, you talked to him too, Val
Yeah, I
yeah,
did.
and Andy.
yeah.
Yeah, but
If you
he,
haven't been on it for a while, it can be hard to sign into.
yeah, and it kind of sounds like he has had a couple pops, if you know what I mean.
Yes.
Yeah, he might just be tired though, you know. That's okay. I've been there
Either way,
a couple
both
times.
make it more difficult to figure out technology. Technology is difficult enough as it is.
Eric's my bro from another Mo. He's been my bass player since I first heard him hit the first note. I was hooked. I was like, I gotta have you, because he just
Yeah,
plays the shit out of that bass, man.
he
I just,
does.
I just love it. Yeah,
He does.
and he
I'm
can
still
play
waiting
sax.
for.
There's nothing the guy can't fix.
Oh, I'd
He's like
like
a,
to hear a saxophone from him.
oh yeah, oh yeah. He's gifted, you know. I call him a genius
Yeah.
because I think he is. But he's my friend,
Well,
you know.
he may very well be a genius.
If he doesn't come in here in the next 10 or 15, we're going to get back to the video.
No problem.
And no, but you guys keep talking, okay? Because I like that.
Well,
I like getting Andy
well,
talking.
mate.
He's always listening.
Greg, we can go back to a video, and then when Eric does get in,
Yeah.
go into the talk.
Okay, we can do that. Yeah.
We can
Yeah,
do
we
that.
can do that.
Yeah, I wanted
Yeah.
to talk to you guys about the Edmund Fitzgerald. Have you ever heard the story of the Edmund Fitzgerald?
Yeah, I have.
Absolutely.
Oh, yeah. Well, you should know about it, Val. I was 17 when it sunk in Lake Superior. It was a huge 730-foot freighter. I got a little story on that. I'm going to play later. Maybe. And
My 13-year-old son was obsessed with shipwrecks for many years between
oh,
the
they're
ages
interesting.
of 4 and 7, I would say. He was very obsessed with shipwrecks, and
I'm
then it
still
became
obsessed.
tornado. Well, he learned all he could at that point in time, and then he moved on to tornadoes.
Hmm.
Son, would you like to talk about the Edmund Fitzgerald? No? Bored with that one now?
Oh, the Edmund Fitzgerald rocks, man. I mean, the story, it's just, I don't know. I guess it was the song that made it so popular. It's a great
Yeah.
song. But it's
He
just
just- he
really
just-
terrible what happened to those guys, man.
He came,
I
he
couldn't
came out
imagine.
for something to relieve himself, and he's going back into his gaming cave.
That's what my son does, yeah. All right,
Mine's
well,
13.
what? Yours is 13?
Yeah.
His voice is already dropped.
Oh, yes, very
Man,
much
when
so.
I listened to Nathan when he was 7, I have a recording of him telling me to get up. Chop, chop, get up, Daddy, get up. He was 7, you know. Now he's like, rah, rah, rah. He's got this big, deep voice. I'm like, man, where did that little kid voice go?
Right?
Yeah.
And my son's voice just dropped a lot in the last year. It started dropping prior, but
Mhm.
my 13-year-old is 5'10".
Mhm.
He's a rather large 13-year-old.
Yeah, Nate's 6'4".
Yeah.
I
Nate's
used to look
6'4".
down on him. Yeah, he's 6'4". I used to look down
Wow.
on him. Now I look up to him. Well, I'm
I
6'2".
didn't realize he was quite that tall.
Mm-hmm. Yeah.
I
His
knew
mom's
y'all
tall.
were. I knew y'all were all
Yeah.
pretty tall.
We're
but
the
I didn't
tall
realize-
family.
I didn't realize he was quite that tall.
Yeah, that he is.
How tall is your daughter?
Olivia? I
Yes.
would say 5'9". She's a big girl, too.
She's about my little taller than me. I started to shrink, but
Yeah. Yeah, we all do. Yeah, I might be
And-
6'1"
and
and 3/4.
Greg's what, 6 or 6'1"?
He's just made 6, barely.
Yeah, he's the shorty of the family.
You know, his mom was 5'4".
Yeah, and I remember your mom. She wasn't very large
My
of a woman.
mom was 5'7". About
Yeah, she wasn't a very
135.
large.
She was never
She
heavy.
was-
She always had, she always had a good weight. Never carried too much
She-
weight.
Put together. I remember that about her. That was one of my very first impressions, was how slim and put together she was.
Oh yeah, yeah. My mom, she was a
Especially-
looker in her day. And she's a good-looking woman. I have a picture of
Yeah.
her when she was 27. She was beautiful.
I definitely thought, especially for her age at that point,
Hmm.
we're going back a while, but
And yeah.
I mean, what?
Well, she passed away in 2001, so it's probably
Yes.
before that. But I mean, it just came on and took
Yeah.
her like that.
95,
Uh-huh.
1995.
Oh yeah, yeah. Greg was staying
Oh.
with her.
Yeah. Oh, that's how I met your mom, and I liked her a lot.
She was awesome. Not a
Really
day
did.
goes by that I don't think about my parents.
It's funny, when I drive down Gratiot, I always look down that road. Always
the
look down that
cemetery?
road.
Yeah, we're Aaron
No.
Grove.
Well,
Oh,
where
Moser?
the house,
Yeah.
Yeah, where the house was.
Huntington or
And then
Mosen?
I'm not trying to give out too much information about
Yeah. Okay.
places
They
we live,
don't. They
but
don't.
you know what I
Yeah.
mean.
Yeah.
But
Actually,
yeah, smoker, and
I
then
lived on a street called Huntington.
yep,
Yeah. You remember
I know
that?
where that. When I drive down Grossbeck, I always look
Yeah.
there,
Mm-hmm.
and those are just places I remember. Or if I'm out riding with my husband, I'm like, that's where I hung out. I hung out there. These are the streets I hung out on in my teen years. These were the people that lived on these streets. So he
I
kind of
see
has
that.
enough
Yeah. I'm sorry.
how I
I wasn't listening. I see here that Eric did join. He's in the server. I see his name, Gar. But he's just, for some reason, he can't find the. Oh,
he's got
wow.
to join the great.
Well, let's break for the rest of the movie and then we'll come back.
Okay, sounds good.
All right. I'll see you in a
All
bit.
right.
Thanks, Andy.
See you
And
soon,
Val,
Greg.
thanks for helping me.
See ya.
See ya.
Charge embedded in the space itself, Berkeley currents. What we shall call a space infracharge. Literally, the space
All right, we'll see you in a
infracharge
little bit.
means that a vacuum, empty space, contains normally unavailable electric charges, here electrons, which generate the structure of that space and affect the behavior and properties of all matter occupying the space. End of chapter. That has to be the longest chapter I think I've ever read. Chapter 3. If this stuff was in some kind of great conflict, with the usual stuff, I wouldn't read it because I wouldn't want to confuse anyone, but it appears to me that it's right along the same lines as
Thornhill and Velikovsky.
He's just given us a different plane to think on, I guess. I always kind of wanted to know how the sun moved in the galaxy. So that was good information. Chapter 4. Super Uranus and the Primitive Planets. About 1 million years ago, our sun, then a supersun, underwent a nova eruption because of a sudden or unendurable change in electrical conditions. Solaria Binaria was instantly born. The sun fissioned, and in a huge blossoming cloud there would have been a diminished sun. With a concentration of gases from the old sun would occur an admixture of chunks of the old sun's interior material, nucleus, including a body that became the binary partner, which we here call Super Uranus. Between the new sun and Super Uranus lingered other fragments of the fission and great quantities of the material that were to be absorbed into the planets. This impressive electrical quantivolution occurred in a matter of hours. The separation of the two bodies increased rapidly. In electrical and chemical terms, we begin to detail this quantivolution. The normal flow of electricity between a star, the cavity, and the surrounding space is inward, as shown in Figure 6. The original supersun was such a star transacting quietly with the electron-rich space around it. The supersun became unstable, as outlined in Chapter 3, when its galactic journey carried it into a less electron-rich region. Here, the enrichment presumably was rapid and of great magnitude, producing a quantivolution. The resulting nova, which is an explosion of electrons that forces, requires a material accompaniment created by Solaria Binaria. The Sun, for a short time, was relatively too electron-rich. In an explosive expansion, the binary was born, not just from the solar atmosphere, but also from the refractory materials normally hidden within its interior. Figure 6. Electron flow from surrounding space into a star cavity. The Sun and other stars represent electron-deficient regions within the galaxy. These regions, cavities as we call them, transact with the space around them, gaining electrons during their lifetime of their central stars. When they become filled, the stars they contain cease to exist. The first state of Solaria Binaria is shown in Figure 7 below. The nova explosion had propelled what temporarily was excess charge away from the Sun. This, of course, would be illusory for the Sun. By its continued existence, remained a region of relative electron deficiency. Thus, the initial dismemberment of the original supersun quickly halted. The expansion of the plenum of material now surrounding the Sun ceased, both because of the Sun's need for electrons and because the charged surrounding medium continued moving in upon the cavity. The boundary of the plenum shown above is actually a quantitative concept to denote the region where the outward pressure created by the charge, Solaria Binaria, is equal to the inward pressure normally produced by the Sun's galactic cosmic transaction. At birth, the electrical state of Solaria Binaria was rapidly layered. The system can best be described in terms of the local charge density of both the material and of the space into which the material was ejected in the eruption. The highest relative charge density existed at the perimeter of the plenum. Inwards, this density decreased. The fragments ejected from the Sun, the debris forming the planets and super Uranus, had progressively higher charge densities than the Sun, which had the least charge density in the system. The Sun seeks its lost charge. The easiest way to get that charge is to launch into the plenum electron-deficient atoms, ions. The proximity of super Uranus distorted greatly what otherwise would have been a radical flow of ions, as in the original transaction between the super Sun and the galaxy. A strong electrical connection coupled the Sun and super Uranus. A lesser connection joined the Sun to the plenum, as shown in Figure 8. See Technical Note E. This connection involved an inward flow of charge through the plenum. The charge flowed inwards either by direct transport of electrons or by indirect electron transport accomplished through the outward flow of electron-deficient atoms, ions. See Technical Note B. The strongest electrical transaction occurred between the principles accompanying this electrical flow. Highly influenced by it was the transfer of material from one of the principles to the other, elsewhere, whose binary systems exist, where the flow is from the companion to the primary. More common is the flow from the primary to the companion. Mitten, page 100. The amount of flow and its direction would depend upon the distance between the specific charge ratio on the principles. We favor the flow of ions and gas from the Sun to super Uranus, since we often cannot resolve the principles into separate stars. Designation of one as the primary and the other as the companion is somewhat arbitrary. The choice usually is dictated by theory. Figure 7. The birth of Solaria Binaria. At its birth, Solaria Binaria was embedded at the center of a plenum filling a sac of electron-deficient matter. Electron flow into the sac from the galaxy was augmented by the electron distribution within the plenum and among the components of the binary system. Ionized gas atoms would be induced to flow between the principles. This flow of counter-moving electrons and electron-deficient atoms would constitute a strong electrical current. As a consequence, an intense magnetic field would be generated surrounding the current. This magnetic field would pinch the flowing ions produced by a relatively narrow electrical flow channel. Collisions between neutral and electrified atoms would transfer the influence of the magnetic field, which affects only the electron-deficient atoms directly, to all of the gas between the principles. The result is a magnetic bottle. Figure 8. Material flow coupling the Sun, Super Uranus, and the electrified plenum. The creation of the Sun's companion, Super Uranus, greatly distorted the electrical flow between the electron-deficient Sun and the galaxy. The Sun's daughter, Super Uranus, like its parent, was short of electrons compared to galactic space outside the sac. The electrical flow coupling both the two stars and the stars within the galaxy caused and directed a significant material exchange between the pair of stars. From the solar wind, protons moving past the Earth, Juergens, 1977, page 28, has calculated the current flowing away from the Sun in a sheet localized close to the ecliptic plane. If this same ion current was once flowing through the electrical channel, then the magnetic field generated was several thousand Gauss in strength. Such a field would adequately constrain most of the gases, producing a gaseous column or axis between the two stars. Material has been found along the interstellar axis in several binary systems. Figure 9. The flow of material between the Sun and Super Uranus. Under the influence of a self-generated magnetic field, electrically charged material flowing between the Sun and Super Uranus generated a strong magnetic field about the axis between the two stars. The effect of the magnetic field was to squeeze all material flow into a thin tube joining the stars. So constrained, the charged matter flow constituted a potent electric discharge, the arc through the gases and matter of the plenum. The absence of an appreciable interplanetary magnetic field, despite the magnitude of the electric current represented by today's solar wind, is understandable in terms of a planar current sheet model, as shown in Figure 10. The solar wind sheet produces opposite toroidal, donut-shaped magnetic regions above and below the planetary plane of motion. In the region between the toroids, the magnetic fields generated by the radially diverging ions act so as to cancel out one another, as in Figure 11. The vector sum of the magnetic intensity cancels out between the parallel flowing ions, but survives on their perimeter, leaving the postulated toroidal field. So, the regions above and below the Sun can be strongly magnetic, while interplanetary space so far explored lies outside of the toroidal field region and has been shown to be almost devoid of magnetism. The existence of the magnetic toroid above and below the Sun may be responsible for the planarity of today's planetary region and the enchantment of the solar wind flow in that plane. Figure 10. Magnetic toroidal field produced by a solar wind current sheet. Assuming that the solar wind is concentrated about the plane of the orbiting planets, the outward flow of ions from the Sun would represent a sheet of electric current. A significant magnetic field curved upon itself to form a donut, a torus, would be generated by the existence of the solar current sheet. This toroidal magnetic field should be found in the space above and below the space occupied by the solar wind. The sun's rotation began consequent to nova discharge, creating Super Uranus. Super Uranus thereafter wheeled about the sun in a close orbit. The magnetic field produced by their electrical transaction was instrumental in locking the rotation of the sun to the motion of Super Uranus about the sun. Strongly coupled together, the pair rotated, looking like an ever-expanding but otherwise rigid dumbbell. The gases and the planets, as they formed, remained trapped along the gaseous electrified axis between the principles, magnetic fields surrounding several flowing ions. Each moving ion or electron comprises a unit of electrical current. It generates a magnetic field which appears in the plane perpendicular to its motion. When electrical charges flow rapidly, as does the ion wind from the sun, only a tiny magnetic field is apparent in the region between the flowing ions, because the magnetic effect of each ion is cancelled by that of its neighbors. A significant magnetic indication of the electrical flow is found only along the perimeter of the current sheet produced by the radial flow of the ions. Plavik notes that the companion, if less massive than the sun, can always be expected to rotate in synchronism with orbital motion. He states that for all binary systems, synchronism of rotation and revolution seem to occur for orbital periods shorter than 10 days. For longer periods, the synchronism falls except as postulated above. Patton, 1967, notes that some semi-detached binary systems, particularly the algol group, have primaries which rotate appreciably faster than would be expected for orbital synchronism. We see these systems as a large stage of evolution of the binary. Solaria Binaria did not detach in this way until after the Saturnian period. See ahead, chapter 14. Oh, the evolution of Solaria Binaria. There's a Saturnian period. Interesting. The evolution of Solaria Binaria was such that the two principles were slowly driven apart, in part by the momentum of the flow of mass from one to the other, and in part from increased repulsion caused by the growing level of electric charge in the whole system, by the accumulation of galactic electrons. All the while, the angular momentum, spin, within the system was being transferred from the primary to its companion. At fission, the sun could have had over 80% of the angular momentum. The evolved binary, today's solar system, left less than 1% of the angular momentum of the sun. If matter was transferred mechanically from the heavier sun to the lighter orbiting Super Uranus, the spin of the binary would decrease, but if the transferred matter is electrically driven, acceleration would be expected to accompany the transfer, thereby potentially increasing the spin of the binary. Even if no increase in spin occurs, and even with the slight slowdown of spin, angular momentum is slowly lost by the sun and gained by its companion and the primitive planets as the electric transfer continues. The pulling apart of the principles was reflected in an increase in the binary's period of revolution. That is, Solaria Binaria wheeled more slowly about its center. There is a significant relationship between the period of revolution of binaries and the observed surface temperature of the primary star. Certain stars, called early type by astronomers, tend to have companions with shorter periods. In its earlier stages, Solaria Binaria would have looked to a distant observer as a close binary with an unseen companion. We imply that the sun was an early type star, but not in the usual sense of the term star. Within the sac where the two stars and the Earth were located, the energy flow may always have been similar to what we observe now. However, the outer parts of the sac were transacting intensively with the cosmos, and thus were radiating so as to appear markedly hotter. The perimeter of Solaria Binaria then would have been to radiate as an early type star, and not like the Sun does now. See Figure 21. Its period of light variation, radiation emitted, and flow of mass would have attracted the attention of astronomers elsewhere to Solaria Binaria. Some curious age disparities exist between principles of binary systems. If the Sirius star system, a young main sequence star, is orbited by a less massive old white dwarf star, the B emission stars, hot, very rapidly rotating main sequence stars surrounded by a shell of gas, are often spectroscopic binaries whose companions orbit in about 10 days. The companion is usually invisible and believed to be a highly evolved star relative to the primary. The highly evolved component, admittedly, often has so little mass that a nuclear synthetic evolution could not have aged it so rapidly. Both the age disparities and the size anomalies disappear if the electrical evolution is considered. It is noteworthy that many of the interesting close binary systems involve an unseen companion. The primaries in these systems range from very hot type O stars to very cool type M stars. The sizes and masses within these star systems are inferred conventionally from the theory of evolution for the thermonuclear star, thermonuclear fusion. We do not agree with such an interpretation of this evidence. We will not pursue the stages of early evolution of Solaria Binaria here. For that, see Part 2. These unaware men saw the skies in the age of Urania about 13,000 current years before the present. There are no humans capable of comprehending Solaria Binaria before it began to break up, at the end of an Earth age that we shall call Pangea. Super Uranus was first revealed to humans as a luminous object about twice the size of the Sun we observe today. The Earth was then located about 2/3 of the distance from the Sun to Super Uranus, because it was still electromagnetically bound to the axis between the stars. The objects found within the inner regions of galaxies seemingly orbit in this way, and probably for the same reason. With such a configuration, the Sun, if visible, would have been seen from the Earth's southern hemisphere only, and would appear 2.5 times larger than Super Uranus, which in its turn was visibly only from the northern hemisphere. The hemispheres referred to here are not those inscribed on the Earth globes of today. They refer to the ancient references to the sky gods and their places. The Earth moved with its north locked towards Super Uranus. See ahead to Figure 18. No other major gaseous planet was within existence at this time. As the solid wheel binary evolved, the Sun eventually was separated from Super Uranus by 105 gigameters, about 0.7 astronomical units. That number comes up a lot. Before the next great quantivolution, the primitive planets, Mars, Earth, Apollo, and Mercury, ended up between the two principles in the region between 61 and 96 gigameters from the Sun. At such separation, this would bring the planet Mars and Mercury closer to the Earth, by factors of 4 and 6 respectively. Even so, these planets would produce visible disks, which were only about 1/27th the size of today's moon. As they could be seen, which we doubt, they would still be observed almost as points of light in the sky. Planets were originally debris from the super-sun nova. They traveled out in the trail of Super Uranus, held in the electric and gaseous flow. They settled into their original positions rather than moving on, because they were electrically less negative than Super Uranus. They distributed themselves in their magnetic cage along the axis in accord with the principle of maximum mutual repulsion, elsewhere known as the principle of least interaction action. See Ovenden, 1974. Several cosmogonies involve processes occurring within a binary star system. Gunn proposes that planets arise from the breakup of a rotationally unstable star. The same process by which he accounts for the formation of a binary star system from a single star, Littleton, 1936, visualizes a process by which planets form during an encounter of a star with two other stars. For such an encounter between three stars to be likely, the stars must formally be members of a bound system of stars. A triple star system, Bruce, 1944, like Gunn, sees the process of planet formation as a single case of fission of one star into a binary. From the beginning, Solaria Binaria was enveloped in a cloud of solar material, gases and solids. As the binary evolved, this sac became extended along the lengthening axis from Sun to Super Uranus, compressed by the magnetic field generated by flowing electrified gases. A stable gaseous tube surrounded the planets. Indeed, these gases pervaded the entire planetary region, enveloping all of the planets in a single sac of gases. Within this dense gaseous sac, the contents of which the ancients called the ether, we will call the plenum. The planets could receive biologically necessary temperatures from the actual electrical discharge connecting the Sun with Super Uranus, de Grazia, 1981. If today's aircraft had existed then, they might have flown regularly among the planets. Very interesting. The approximate size of the gaseous tube within which the Earth and the other planets moved was at most the diameter of the Sun, and at least a significant fraction of the diameter of Super Uranus. This tube confined the plenum, which allowed life to develop and thrive on all of the planets of Solaria Binaria. End of chapter. Got chapter 5 coming up next. And, I'm not adopting this book, as you may know. I'm just reading it because it's interesting and it's another take. So it gives us something, another plateau to think on, But I'm not reading it because I've accepted it. I just wanted to make that clear. Okay. I'll talk to you. Chapter 5 will be coming soon. Thank you. Chapter 5, The Sac and its Plenum. The original supersun, prior to its nova, was accumulating electrons from the galaxy, consistent with the demands of the environment through which it was passing. As we have explained earlier, the supersun became too electronegative and expelled material violently into its surrounding space. This material could not escape. Its expulsion was exposed both by the post-nova sun and by the galaxy. It thus formed and filled a sac surrounding the newly created Solaria Binaria. In the sac was the whole system of Solaria Binaria: the Sun, Super Uranus, the primitive planets, and the plenum of gases and solids of solar origin that nurtured the planets. As the binary widens, the sac becomes conical in shape, narrowing from the size of the Sun at one end to about the size of Super Uranus at the other. A system of similar appearance has been postulated for the binary AM Hercules. Wickramasny and Basel describe gas flow patterns in X-ray emitting binary systems there. One may note a similarity in the shape of their pattern of maximum obscuration to the cone of gases proposed in this work. Viewed from the outside, the ancient plenum would have been opaque to light. Not so with the gas of Earth's atmosphere today, which is 8 kilometers thick. If the atmosphere is considered as a column of gas of consistent density, this atmospheric layer is of trivial thickness compared to the radius of the Earth. Yet, its importance to the environment is unquestionable. Even this negligible atmospheric layer removes 18.4% of the incoming sunlight, mostly by diverting it from its original direction of travel. Some of this scattered light returns to space, but most of it is redirected several times to produce the blue sky so familiar to us. Atmospheric scatter is enhanced near sunset, when the incoming light traverses an atmospheric column tens of times longer than near noon. The setting sun is notably fainter, and it's colder, redder, because of the increased scatter. If the atmospheric column were as little as 1,280 kilometers thick at present surface air density, all of the sunlight would be deflected from its incoming direction. Light would still be seen, but only after scattering several times. No discernible source could be identified with the light. So it was in the days of Solaria Binaria. To be precise, if in the last days of Super Uranus, this body were about 30 gigameters from Earth, and if Super Uranus was then as bright per square centimeter of the surface as today's sun, it would not have been directly visible unless the gas density in the plenum was close to that deduced today for the Earth's atmosphere. At an altitude of 80 kilometers, to see more distant sun, this density would have to be decreased another fourfold. In the age of Urania, Super Uranus was located about as far from the sun as the orbit of the planet Venus today, as would provide the plenum with a volume of about 10 to the 20 cubic kilometers. If the plenum contained as much as 1% of the atoms in the present sun, the gas density would be several times that found at the base of Earth's atmosphere today. Neither star would be seen directly. Only a dim, diffused light could reach the planetary surfaces. As the Binaria evolved, the plenum came to contain an increased electrical charge. It expanded, leaving less and less gas in the space between the principles. Thus, it became gradually more transparent. Astronomers see diluting plenum gases elsewhere in evolving binary systems. Batten, 1973, page 10. Discussing matter flow within binary systems favors gas densities of the order of 10 to the 13 particles per cubic centimeter. Warner and Nather propose a much higher density for one system, U Geminorum, a dwarf nova system, where they postulate a gas disk with 6 times 10 to the 17 electrons per cubic centimeter. Unless all the gas is ionized, the neutral gas density would be higher than the calculated electron density. The gas densities that they mention are comparable to those necessary to allow the early humans to discern the first celestial orbits. In earlier stages of Solaria Binaria, the plenum was impenetrable to an outside. I'm obviously taking it that this took eons in time, because according to them, life is already on the planets when it's in this phase. In earlier stages of Solaria Binaria, the plenum was impenetrable to an outside observer. All detected radiation came from the surface layers of the cone-shaped sac, an area up to 55 times the surface of the sun. The luminosity of the sac would arise from the transaction between inflowing galactic electrons and the gases on the perimeter of the sac. The plenum at formation was electron-rich relative to the stars and the planetary nuclei centered within it. These latter electron-deficient bodies promptly initiated a transaction to obtain more electrons by expelling electron-deficient atoms into the volume of the plenum. The charge differences within the sac were modulated with time. In other words, the plenum was losing electrons from its perimeter to its center. In response, the size of the sac collapsed under cosmic pressure. In time, this charge redistribution might have diminished the volume of the sac by as much as tenfold, compressing the cone of gases into a cylinder or column of small diameter. Running along the axis between the Sun and Super Uranus was an electrical discharge joining the two principles. Moving with this electrical flow was matter from the Sun that was bound for Super Uranus. Some of this matter would be intercepted by and incorporated into the primitive planets. Induced by the electrical flow, a magnetic field was generated, which encircled the axis and rapidly pinched the gases. The pinch effect is self-limiting, in that the more the current, the more the pinch. An infinite current, in theory, pinches the current carriers into an infinitesimal volume. The plenum at formation was electron-rich, relative to the stars and the planetary nuclei centered within it. These latter electron-deficient bodies promptly initiated a transaction to obtain more electrons by expelling electron-deficient atoms into the volume of the plenum. The charge differences within the sac were modulated with time. In other words, the plenum was losing electrons from its perimeter to its center. In response, the size of the sac collapsed under cosmic pressure. In time, this charge redistribution might have diminished the volume of the sac by as much as tenfold, compressing the cone of gases into a cylinder or column of small diameter. Running along the axis between the Sun and Super Uranus was an electrical discharge joining the two principles. Moving with this electrical flow was matter from the Sun that was bound for Super Uranus. Some of this matter would be intercepted by and incorporated into the primitive planets. Induced by the electrical flow, a magnetic field was generated, which encircled the axis and rapidly pinched the gases. The pinch effect is self-limiting, in that the more current, the more the pinch. An infinite current, in theory, pinches the current carriers into an infinitesimal volume, extinguishing it. Blevin, 1964, page 214. Material would be extruded at both ends of the pinched flow by the pressure induced in the pinch. This circular magnetic field, a magnetic tube, would induce randomly moving ions of the plenum to circulate along the field direction. The circulating motion of the ions eventually would be transferred by collision to the neutral gases. The result would be in the outer regions flow would be dominated by revolution around the circumference of the tube. Everything here would eventually revolve uniformly. The innermost regions of the column were dominated by flow along the axis. Considerable transaction occurred at the junction of these two separately moving regions of the column, the central and the peripheral. Some luminosity would arise from the transaction of electrons and ions deep within the magnetic tube. The ions, electrically accelerated towards Super Uranus, were neutralized at some point along their trajectory. At neutralization, X-rays were produced. Some of the ions would be neutralized upon collision within the magnetic tube, most upon reaching Super Uranus. But because the pinch phenomenon noted above, some ions would be extruded and neutralized near the perimeter of the sac behind Super Uranus. Despite the high gas density in the original plenum, X-ray emission would be observable from the outside. That such is the case elsewhere is indicated by Brennan. As the plenum diluted with time in a manner to be discussed in Chapter 11, the outside observer would see deeper and deeper into the system, and eventually all of the X-ray emission would come from the interference between the magnetic tube and the surface of Super Uranus. As in other binary systems, a partial eclipse of the main X-ray source would then be seen as the dumbbell revolved. See Tannenbaum and Hutchings for data on other binaries. Matsuka notes a positive correlation between X-ray and optical emission in binaries. Radio-emitting regions surround many binary systems. Wick-Ramsingke and Bessel. Spangler and his colleagues claim that radio emission from binary stars is noted for stars that are over-luminous. The radio emission is generated by electrons transacting with the magnetic field associated with the inner star axis. That is, emission is enhanced when a stronger transaction occurs between the stars, causing the overluminosity is understandable using our model. Despite the high gas density in the original plenum, X-ray emission would be observable from the outside. That such is the case elsewhere is indicated by Brennan. As the plenum diluted with time in a manner to be discussed in Chapter 11, the outside observer would see deeper and deeper into the system, and eventually all of the X-ray emission would come from the interference between the magnetic tube and the surface of Super Uranus. As in other binary systems, a partial eclipse of the main X-ray source would then be seen as the dumbbell revolved. See Tannenbaum and Hutchings for data on other binaries. Matsuka notes a positive correlation between X-ray and optical emission in binaries. Radio-emitting regions surround many binary systems. Wick-Ramsingke and Bessel. Spangler and his colleagues claim that radio emission from binary stars is noted for stars that are over-luminous. The radio emission is generated by electrons transacting with the magnetic field associated with the inner star axis. That is, emission is enhanced when a stronger transaction occurs between the stars, causing the overluminosity is understandable using our model. At the perimeter of the plenum, optical effects would show to an outside observer an apparent absorption shell associated with the hidden binary within. Like many of the close binary systems, the stars of Solaria Binaria would not be resolvable in a distant telescope, but the binary nature of the system could be known because observable differences could be produced as the dumbbell revolved. Gas-containing binary systems, as described here and elsewhere, Batten, 1973, represent the stake of Solaria Binaria at various epochs, and especially in its last days. As the binary system collapsed, the plenum thinned, allowing direct observation of light produced by sources inside the sac. The gas disk, theoretically implied to surround the stars of other binaries, is waning in the late translucent plenum. The gas streams detected flowing between certain binary components are present in Solaria Binaria along what we call the electrical arc, The gas clouds, whose absorption spectrum leads us to believe that they envelope entire binary systems, correspond to the perimeter of the early opaque plenum. As Solaria Binaria evolved, each of the classes of circumstellar matter, noted by astronomers, became observable in their turn. Inferable from the above is the degree of visibility from the Earth's surface or from any point of the planetary belt within the plenum. Overall, there is a translucence. Objects near at hand might be distinguished, certainly after the halfway mark in the million-year history of Solaria Binaria was past. Sky bodies were indistinguishable from Earth. With passing time, the level of light would increase. In the beginning, the light is scattered, and the sky is a dim white. As the plenum thinned electrically, the sky bodies would emerge as diffuse reddish patches. During this process, the sky would brighten and become more blue. Thus, as they emerged, Super Uranus and the Sun brighten and whiten, while the sky becomes darker and bluer. At a time related to the changes soon to be discussed, around 14,000 years ago, the Earth is suddenly peopled by humans. And one may investigate whether any memories remain of the plenum. There seem to be several legendary themes that correlate with our deductions about visibility. Seemingly, Aboriginal legends describe the heavens as hard, heavy, marble-like luminous. Earliest humans were seeing a vault, a dome, probably in retrospect to the heaven, as ascribed the human qualities of a robe or covering, and by extension, part of the anthropomorphic god. Thus, the Romans saw Colus, the Chinese Tien, the Hindus Varuna, and the Greeks Uranus. Vale, 1905 to 1972, presents ample evidence that day and night were uncertain and that the heavens were continuously translucent. When the Hindu myth says the world was dark and asleep until the great demiurge appeared, we construe the word dark as non-bright relative to the sunlight sky that came later. Heaven and earth were close together, were spouses according to Greek and other legends. The global climate of the earth in the plenum was wet. All is born from the insemination of the fecund earth by the sky, said some legends. There was so much moisture in the plenum that although the ocean basins were not yet structured, first proto-humans might confuse the waters of the firmament above with the earth waters. In some legendary beginnings, a supreme deity had dispatched a diver to bring out earth from the great primordial waters of chaos, and the earliest condition was referred to as a chaos, not in the present sense of turbulent clouds, disorder, and disaster, but in the sense of lacking precise indicators of order, such as a cycle that would let time be measured. Tien is the Chinese heaven. I hope I'm pronouncing that right. Universally present chaos without form. The gods who later give men time, such as Kronos, are specifically celebrated. Therefore, Plato, sky bodies were invisible. Legends of creation do not begin with a bright sky filled with beings, but speak of a time before this, when the first sky body observations were reported. They are of falling bodies. The earliest fixed heavenly body in legend is not the sun, the moon, the planets, nor the stars, but Super Uranus, as will be described later on. Nor was the radiant perimeter of the sac visible. It lay far beyond discernment, as such, and was, in any case, practically indistinguishable from its luminescence. The electrical arc would have been visible directly only in its decaying days, being likewise sheathed from sight by dense atmosphere of the tube that the arc or axis appeared along with the sky bodies. Before its radiance expired is to be determined in the next chapter, where its composition and operation are discussed. End of chapter. A quick one. Chapter 6. The electrical axis and its gaseous radiation. The binary electrical system was distinguished by an electrical flow between the principles. This was a highly energetic discharge, which generated chemical and probably nuclear transformations among the gaseous constituents of the plenum. It provided the heat, energy, for life to emerge. The gaseous plenum initially seems to have contained an excess of hydrogen. The combination of electrical arc and hydrogen-rich gases favored the quick production of organic molecules of the biological systems, Miller and Urey, within the plenum. An electrical current flowing along the axis of the binary of the order of 10 to the 14th amperes, 100 teraamperes, would produce sufficient magnetic field intensity to constrain the plenum gases up to 64,000 kilometers from the axis. See ahead to Chapter 7. Electrical breakdown can occur in dense gases where the electrical field intensity is of the order of 25 kilovolts per centimeter. The longer the electrical column, the greater the potential difference required between the principles in order for breakdown to occur. Once breakdown occurs, the voltage drop at a place decreases from kilovolts per centimeter to tenths of a volt per centimeter. Along the discharge column, the voltage drop varies considerably. It is greatest near the electrodes and is very small at most points in the body of the discharge. It is difficult to estimate the energy that would be released by a discharging arc unless the voltage drop across the arc is known. Since we do not know this value for Solaria Binaria, we must define the arc's parameters in terms of other criteria. One must be preoccupied with the thermal constraints upon the Earth and its developing biosphere. It is known that transverse heat flow is hindered by the presence of a strong magnetic field. Also, the gases, insulated, diffused, and rendered uniform, the intermittent blasts of the arc by the time the radiation reached the region occupied by the planets. Nevertheless, the closer the Earth to the arc, the more energy it would have received. For some time, the Earth gained its energy almost entirely from the arc source. It is reasonable to assume that Earth's temperature must soon have developed below 325 Kelvin. If the Earth to arc distance is chosen to be fixed at 64,000 kilometers from the arc, the Earth is irrotational with respect to the arc, and it absorbs all incoming energy. See ahead to Chapter 13. The heat flowing away from the binary arc cannot much exceed 2.6 times 10 to the 14 watts per kilometer of arc. Such an arc would dissipate at least 3.1 times 10 to the 22nd watts within the sec. Given the constraints to radial heat flow cited above, the actual arc could have been much more energetic than we calculate here. Thus, the discharge should have produced a small region of hot gas centered along the electrical axis. Surrounding the gases of the discharge was a large opaque mantle of cool gases. Within the cooler gases were the electrically charged planets, which had been repelled from the arc but caught up in the magnetic tube. See ahead, Chapter 7. In terrestrial lightning, the period of electrical buildup, leader process, compared to time of discharge, return stroke, is in the ratio of hundreds to 1. The recovery time before the next stroke has built up is often 800 times the duration of the stroke. Thus, it would be reasonable to conceive of the Solaria Binaria arc as discharging about 1,000th of the time. A lightning bolt leader moves about 300 kilometers per second. Thus, late in the history of Solaria Binaria, it would have taken about 350,000 seconds for the leader to work its way along the 105 gigameters between the principles. The return discharge propagates faster, taking only 2,190 seconds, or 36.5 minutes. I wonder how he figured all this out. Did this art, so necessary to life, persist even into the time of human awareness? As Super Uranus receded from the Sun, and the planets redistributed themselves further apart in its wake, it is logical to assume that the intensity of the arc declined, and its flow became intermittent. Hence, at around 13,000 years before the present, an observer on Earth would have seen a great flickering and coiling axis or cone of fire. Solaria's electrical binary connection differs from a terrestrial lightning stroke of today in that it involves many concurrent, but not necessarily simultaneously launched, arc channels. A close analogy would be the granular cells seen at the bottom of the discharge channels between the galaxy and the surface of today's Sun. In this latter case, the difference between the arc in Solaria Binaria and the radially directed discharges on today's Sun is the absence of a closely spaced, non-electrically neutral companion body. This proximity, which was present in Solaria Binaria, induced a continual series of electrical explosions to be conducted along the electrical tube joining the closest localities of the surfaces of the two stars. The plenum gases at this time, especially near the arc, were dense enough to be opaque to radiation. A discharge that is opaque appears to radiate from its surface rather than from the whole volume of gas. In consequence, energy flows diffusely away from the central discharge into the surrounding gas, some as radiant energy, some as the flow of excited matter, some by thermal conduction, by kinetic energy exchange and collision. Collisions will act so as to maintain an outward flow of energy. Somerville. Usually, ions and electrons diffuse radially from the column. Later, they recombine, giving up the energy of ionization to the gas. Also, excited atoms, especially those which are long-lived, flow away from the column, carrying internal excitation energy, which they can release when deactivated by a collision with the non-excited atom or molecule. I heard that atoms never die. You know, if that's true, it's just what I heard. The relative importance of radiation when contrasted with conduction for redistributing the arc's energy will depend upon the composition of the gas and the gas pressure. Some gases, like hydrogen and helium, are not efficient radiators of visible light. However, for all gases, high pressure makes radiation more important than conduction in the transfer of energy. In the laboratory, electric arc current flows are of the order of 10 amperes per square centimeter. If such an arc were to flow between the early Sun and its close companion Super Uranus, it needs strike only a rather small area of the latter. A discharge column, if encompassing an area of only 10 to the 13th square centimeters, could produce an arc current of 100 terramperes. In an electric arc, the gases burn in a relatively narrow column. The higher the gas pressure, the narrower the discharge column, and the more difficult it becomes to sustain a uniform current through the discharge. Somerville. Strong arc discharges, such as lightning channels, seem to bend in helical shape. Such bending seems to generate a condition within the arc which can terminate the discharge. Non-electrical gradients in the conducting electrified gases are usually offered as explanation for the curving of the discharge channel. These mechanical drifts set up within electrical discharges are probably better explained as electrical drifts, but neither explanation goes very far at present. Revolution of the gases around the longitudinal axis of laboratory discharge columns tends to stabilize the discharges. When they do, the rotating gases are said to create a radial gravitational field. Somerville. Similar vortical stabilization is noted in rotating air. It is suggested in tornadoes, where almost continuous vertical lightning activity occurs. The rotating gases surrounding and driven by the magnetic tube in Solaria Binaria would act to keep the electric discharge going when it otherwise would have gone out. In the laboratory, high current discharges are so unstable that continuous operation is not easily maintained. The pinch effect usually extinguishes the discharge. Within the current removed magnetic field, relaxation occurs so that hot electrified gases begin to diffuse away, cooling the discharge column. Electrical forces quickly establish the current, stopping the outward flow of hot matter. So it was too in Solaria Binaria. The arc pulsed regularly, responding to some natural rhythm between the forces leading to extinction and the forces promoting resurrection. High gas densities favor brief, frequently reoccurring pulses of arcs. Could this mechanism be the origin of the regular pulses of radiation observed in celestial objects called pulsars? As the gas density decreases, the arc's pulsing frequency would decline. Pulsars show a slowing of the pulse rate with time. I would imagine that a big enough plasmoid could be mistaken for a pulsar. But, it's a good question. The electric arc operating in Solaria Binaria is a cosmic discharge of long duration in the course of 17 letters about cosmic electrical discharges. 1958 to 1964 has documented examples of smaller arcs of shorter duration and of longer arcs lasting to millions of years. We concur with this conclusion that electric discharges on a cosmic scale explain many phenomena observed in the astronomical realm. Bruce has convinced us that only scale differentiates lightning discharges observed regularly in the Earth's troposphere from solar flares, periodic discharges in the giant envelopes of gases surrounding certain variable stars, and the enormous eruptions moving through the entire volumes of certain active galaxies. He proposed that an electric discharge liberating energy comparable to that ascribed to the quasars was capable of transforming elliptical galaxies into spirals. It would seem, and that would make sense too, because it's probably exactly the opposite of what mainstream thinks it is. They got everything wrong. It would seem that the quasar phenomenon is, in fact, a galaxy in transformation. Well, there you go. That's Degrassi getting it from Haltenmeyer. This is the grandest of cosmic lightning discharges. In its wake, the spiral arms of the galaxy form with their metal-rich stars, Bruce speculated that in the enormous temperatures generated in these discharges, nucleosynthesis transmutes smaller atoms into larger ones. It is this latter possibility that leads us to postulate that nuclear transformations were accomplished in the arc of Solaria Binaria. If they were, they probably occurred most vigorously at the beginning, when the discharge current was greatest. Despite the many problems with laboratory experimentation in this area, some supportive work has taken place. Using a pulsed, high-current arc discharge, Russian workers produced beams of 40 kilo-electron-volt deuterons at instabilities in the discharge, Somerville, page 55. This achievement is consistent with certain proposed nucleosynthetic processes that occurred in low-energy flares above star surfaces. Canal. SATURN gives us mechanism for the generation of solar flares resembling processes which might occur within regions of a pinched electrical arc. Even more closely related to the situation in Solaria Binaria is just speculation that X-ray burst sources result from thermonuclear flashes. X-ray burst sources are episodic, and some bursts are more frequent. Many burst sources can be inactive for weeks. X-ray sources, steady, and bursters are associated with binary star systems. Now, that stuff is scary. Talking about stars bursting. No thanks. If particularly the burst sources are due to thermonuclear reactions in close binary star systems, then we can be confident that these reactions occurred in Solaria Binaria, and they were instrumental in shaping its chemical and biological structure. In so much as these thermonuclear events were part of an early history of the electrical axis, no human would have observed this part of his ultimate creation. The last chapter mentioned what the earliest true humans would have generally perceived, but it postponed treating their special experience with the electrical axis. A correlation of the electrical axis with early legends about central fire may be probative. At one region of the Earth, the axis might be expected to appear as kind of a rainbow of fire or neon tube glow across the sky, ending at Super Uranus. And another region of the arc might appear more short at the horizon and stretch to the red star in the opposing hemisphere. The arc might be visible alone first, and then might reach for and finally attain the sun, with the axis blossoming at the sun, thus creating it. Or vice versa. The flickering of the arc, when slowed down enough to be noticeable, might resemble red-coiled snakes intertwining and crawling brokenly towards the great red god. Indeed, the snake and dragon accompany very early gods and goddesses. The serpent of the Jupiter-type myth is always seen to be a creation of the proto-Saturn god, Trustman and Ogie Hogan. I've heard that name before, from Velikovsky. That is, Uranus, the Saturnian image with snakes from India. I think it's an alias. And the Chinese painting of the espoused deities shown in figure 12 and figure 32 are suggestive. Serpents are among the earliest symbols of art and myth. The color red is widely used and sacred in archaic, perhaps Paleolithic Iranian times. Rushner. However, the abundance of such symbols is counterbalanced by their generality as reference, lacking specific applications to phenomena. They are an unreliable indication of the electrical axis. Certain symbols associated directly with Saturn of the time of Super Saturn are also suggestive of the arc. These include the courtly long-gowned figure of the god, the tree of life, including the Christmas tree, the sacred mountain, and others. Talbot. that convey the image of the god atop a cone-shaped or pyramidal design on top of the world. Now, Dave Talbot wrote the Saturn myth 4 years before, if I'm not mistaken, 1980. This book came out in 84. In Iroquois land, at the beginning of things, the chief of heaven, in a fit of jealousy towards his spouse, uproots the tree whose flowers illuminate the celestial world. The sun and moon did not exist at the time. He cast his wife, fertile earth, into the hole and replaced the tree. That's terrible. 1967, he laid. The planet Saturn in ancient Indian art. Brahma, planet Saturn, encircled, riding by serpents. Testimony from an early time of the serpent motif in cosmogony, reproduced courtesy of SIS Review. Among the Neju Dayak of Borino, the creator couple, dwelling as birds in the tree of life, and damage the tree badly. Some time after the first humans are born, of their efforts, the tree is destroyed. Jeez. I wonder we're like we are. Linguistic frame of modern science. Like Mother Earth was raped by this guy and beat up and thrown in a hole. Linguistic frame of modern science is the concept of the central fire that occupied early Greek philosophy. This has particularly descended through the fragments attributed to Philios the Pythagorean, Drar. Rose has thoroughly explored the material. Philios was the first of the secretive Pythagoreans to publish a book, and his treatment by Plato leaves little doubt that he represented a considerable school of archaic science. Some 32 attributes of the central fire are to be elicited from Philios and Heraclitus, as presented by Rose, all of which can be accompanied to the theory of the electrical axis of Solaria Binaria. The central fire was thought to have been a layer of fire above a layer of air. It is the center of the world. It is cone-shaped. It never sets and has always the same location in the sky. It is alone the highest, unmoving, stable, the beginning of everything. The earth orbits around the fire, but earth does not rotate upon itself, nor has the earth any obliquity. The fire is not counted among the numbered bodies of celestial sphere. It is not called Saturn, or by any other name except that it was termed the mother of the gods. It is called the hearth of all, the residence of Zeus, his throne, his tower, his fortress. It is a divine ruler and teacher. It is the altar, the bound, and the measure of nature. The sun borrowed light from the fire. The sun orbits around it. The moon, planets, and stars orbit the fire. Heraclitus reported it as an ever-living fire, kindling itself by regular measures and going out by regular measures, he said. That it advances and retires, Rose. Earth turns always the same face towards the fire. A counter-Earth exists, which is closer to the Earth than to the fire, and obscures the fire from view. The match of Solaria Binaria's axis of electrical fire, as electrical discharges were called until the 19th century, with the attributes of the central fire in Greek cosmogony is close. The mention of celestial bodies can be explained as reflecting later observation of some traits. End of chapter. That was a good one. I enjoyed that chapter. Depending on how it does, I'll decide to do the second half or not. Thanks for listening. Take a walk through the universe. Let's see where we live.
This is
Thank you. Chapter 13. The Nova of Super Uranus and Ejection of the Moon. Ancient Mesopotamian accounts of the gods tearing off each other's heads and limbs are not baffling in the context of early human existence, but these and similar stories of the Teutonic, Greek, Roman, Hindu, Iranian, Mexican, Egyptian, and archaic primitive religions are baffling in regard to their positioning in time. Given an empirically established calendar, a general review of the early literature may assign a period to them. Tentatively, we assign these earliest theomachies to a period of Super Uranus instability and the climactic nova of Super Uranus that drastically changed the face of the Earth. According to Hindu accounts, while Adityas and Vitras fought in the troubled first phase of the skies, heaven and earth, living together in a common house, bore Indra. At first concealed, he fed upon Soma until he attained enormous size, whereupon he blew heaven and earth apart forever, filling the atmosphere by himself and exploding the Vitras in the process by thunderbolts. From the exploded belly of Vitra came the cosmic waters, acknowledged Indra, Super Uranus, as their new lord. Out of the waters came also the sun, Varuna, heaven as Super Uranus, presided as order and truth emerged from primordial chaos. This narrative is but one culture's account of mankind's witnessing of the explosion of the celestial body. An alternative from the Vedic period has a cosmic egg, here Super Uranus, floating for 1,000 years in the primordial waters, our plenum, until it burst as a nova, to reveal the Lord of the universe, Purusha. It may be that Purusha is yet another phase of the troubled Super Uranus. From the navel of Purusha sprang a lotus bright as 1,000 suns, possibly an electric arc, whence came Brahma, who acquired Purusha's powers as Lord of the universe, and whom we shall identify below as Super Saturn. Cardona, 1978. The cracking of the cosmic egg may represent the sight of a fissioning Super Uranus in human memory. The Hebrew book of Genesis begins with a primordial light that did not have the company of the celestial bodies until the fourth day. This may have been lightness or a light. The deity may have been Super Uranus, who first gave lightness and then a light of himself. Some, Cordona, place the deity here already into the Saturnian period, justifiably asserting the perennial names and qualities of Elohim and Saturn. We speculate that either Genesis begins after the Super Uranian nova with Super Saturn, or that the great expanse of time, Elohim, and his Uranian role was merged into Elohim in his Saturnian role. Generalizing on this problem, Tressman and Ogie comment that where there is descent from the father to son, it is obvious otherwise the transaction between the original deity and the later Saturn god is not too marked. The Sumerian ideogram for star, god, and heaven, An, is one and the same, a simple 8-pointed star shape. This strongly suggests that they believed the original heaven was a body that later became a star. It also strongly indicates that the first deity was this star heaven god. Tressman Ogie, quoting Kramer. The Egyptians defined Atum as the incomplete one who became complete, says Lowry, citing the coffin text. We may surmise that this heaven becoming a star, Atum, was depicted by the Egyptians as a setting sun. There is every indication that this original deity was at one time the only visible planetary body of the heavens. From the Hindu sources we have, in the beginning, Prajapati existed alone. The Egyptian records tell that Atum was alone in the primeval watery abyss. The deities An, Anu, Sumeric, and Uranus, Greek, were both lone planetary deities, although their names translate literally as heaven. In each case, the successor to the original deity was a Saturn-type god. In the Edda epic of Scandinavia, the spirit brooding over the dark, abysmal water calls order out of chaos, and once having given the impulse to all creation, the first cause returns and remains forevermore. The star in its pre-nova state was apparent from the time of its emergence from out of the gloom into now activated heavens. The interval from 14,000 to 11,000 years ago may be designated as the age of Urania. The skies were falling upon the transformed primate schizoid Homo sapiens. Children's fables like that of Chicken Little, who led the barnyard animals in a search for an authority to do something about the falling skies, are ancient and widespread, and are not to be neglected as reflections of the ancient traumas, imprinted upon the collective memory and sublimated into the first fictional literature alongside the sacred religious myths. De Grazia, when the heavens were broken open, as by Panku, the Chinese creator god, Super Uranus appeared in the north, immense and egg-shaped, probably resembling a giant eye. 2. Atop the sky. At first, the white of the albumen, it became yolk red and radiated heat. It was probably the primordial light of the beginning lines of the Hebrew Genesis. As noted above, the present celestial bodies appeared only on the fourth day of creation. To the south, less luminous because it was much more distant, was the sun. There were now 3 sources of heat: the magnetic tube powered by the arc, the sun, and most prominent of all, Super Uranus, depending upon the earthly observer's location. Either Super Uranus or the sun could be discerned through the thinning gases. In general, northern observers glimpsed Super Uranus, southerners saw the dimmer but larger sun. During this period of instability, Super Uranus erupted regularly. The body of the star contained electric charges distributed internally to be in balance with the charge on the surface, which was transacting with the sun and or the galaxy. The sun, via the arc, had been robbing Super Uranus of electrons for almost 1 million years, a process that kept the surface of Super Uranus relatively drained of charge. Super Uranus' charge-deficient surface could be altered in one of 2 ways: a sudden influx of galactic charge or short-lived disruption of the arc. Both would overcharge the Uranian surface. The reaction would be to further concentrate the charges within Super Uranus, when the surface charge again became reduced, which would happen if the arc suddenly reconnected, allowing a burst of ions into Super Uranus. The interior of Super Uranus, now overly packed with charge, would respond by outbursting charged matter into space. This outburst would not normally escape from the domain of the star which generated it. Most of it would in time be reabsorbed into the star, returning the released charge. Charged debris falling back could help induce conditions for another electric compression and outburst, and so the star erupted cyclically. The cycle of erupting away highly charged material and subsequently reabsorbing it follows directly the notion of a plenum of charged gases around the binary system itself, secondarily around each charged body of the binary. The extent of each plenum is determined by the charge on the body it surrounds and by the charge in the plenum gases. When an eruption occurs, the plenum gases increase in charge and expand their sac. Electric fields are set up which cause charges to flow, thereby decreasing the surrounding charge relative to that within the central body. The plenum then begins to collapse. Pieces within the sac discharge and also fall back. In the age of Urania, each body might be said to possess an autonomous sac and plenum, immersed in the now diluted plenum of the whole system. The plenum of Solaria had by this time become so tenuous that the individual bodies had established around themselves electrospheres, regions of charges, gases, and from time to time solid matter. These spheres, or regional environments, were to their central bodies what the plenum had been to the system, and that they defined the limit of the body's influence upon nearby matter and charges. Vestiges of the electrospheres are found today in the electric sheaths surrounding the Sun and the various planets. The transition occurred mostly in the time of Jupiter. See Chapter 15. The restoration of erupted pieces occurs so long as they do not exceed a certain critical size. Judging by today's solar system, this would seem to be about 22 kilometers in diameter, or a volume of 6,000 cubic kilometers. Pieces that could not be reabsorbed could become satellites of their parent body, as had Super Uranus and the primitive planets. But in Solaria, they could be transferred from the realm of one body to another, whenever the two electrical plena involved were contiguous. In these special circumstances, escape was possible. The smaller sacs could leak gases and pieces into adjoining sacs. This is how Super Uranus bombarded the planets. Its outbursts electrically charged the Earth's sac and filled it with debris of diverse sizes. The cooling Earth, noted during the Uranian period, could be accomplished by several means. As the plenum cleared, more and more of the arc's energy was transmitted directly to the Earth without involving the plenum gases as intermediary. Thus, albedo became more important in the energy transfer. Where earlier the heated plenum kept the Earth warm, now the light conveyed energy directly to the Earth. If the cloudy Earth reflected 52% of the radiation from the arc, the Earth would cool to 270 Kelvin from its former warmer temperature. That's 26 degrees Fahrenheit, -3 Celsius. Alternatively, if the Earth accepted more than half of the light, but the arc cooled, the temperature would also drop, right at 87. Super Uranus ejected a large chunk of its material down the magnetic tube towards the Sun. This element, to be termed Uranus Minor, was preceded and accompanied by gaseous blasts and water, badly out of electrical equilibrium, both because of the electrical cataclysm which ravished Super Uranus, and because the ejects now followed orbits, taking them into regions of greatly different space charge. A vast, brightly glowing space charge sheath surrounded Uranus Major. As it hurtled towards the Earth, See Jerkins, 1972, for a discussion of these sheaths. At the time of the eruption, the Earth is revolving around the arc, moving counterclockwise, viewed from Super Uranus. The globe is oriented with Africa, the Old North, facing the explosion. The magnetic poles lie on the rotational equator, Greenland leading and Antarctica following. At this time, the Earth had a continental crust everywhere. The continents that survive today were bunched around Africa, then located at the north rotational pole. In Figure 27, the land areas of the world today are drawn schematically as they related to Pangean, all Earth times. They accord with the geophysical and paleontological findings of the continental drift school of thought. 88. Uranus Minor, moving from Super Uranus towards the Sun, encounters the outside edge of Earth, the Pacific side, in passing. See Figure 28. An intense transaction occurs between the two. Electrical polarization distorts the shape of both bodies and their sacs, and the Earth's magnetic axis wrenches out of line, which causes the world to shudder. The sudden movement loosens part of the lithosphere. Torrents of water or ice flow or slide across the surface. Fiery blasts strike the area, which is now the West Central Pacific Ocean, opening massive craters, some deep enough to release mantle material previously 30 kilometers below the surface. At perigee, the transaction between Earth and Uranus Minor reaches a maximum. The crust on the side closest to the intruder cracks and fragments explosively. As much as half of the Earth's continental material rises into the sky, leaving exposed much of the upper mantle. This extraction initiates the reshaping of the lithosphere to produce the structure we study today. Whereas, before this event, the entire Earth was topped by a thick granite layer. Basalt was now exposed. In its brief encounter with the Earth, which we estimate to have lasted many hours, Uranus Minor peeled a deep swath of crust and some upper mantle material from the central Pacific, and to less depth from the Great Seamount area west of the Americas. The surviving land from the age of Urania, prior to the eruption of Super Uranus, which hurled the large fragment, Uranus Minor, down. The magnetic tube passed the Earth. Our planet was covered by a complete shell of granitic crust. Much of that crustal layer was lost when the Earth encountered Uranus Minor. That crust which remains was once clustered around the ancient north rotational pole, which then always faced towards Super Uranus. It was ruptured and rifted by the close passage of Uranus Minor. The Earth wobbled eccentrically as mechanical. Electric and magnetic forces acted upon it. Surrounding the wounded surface was a rampart of devastating granites. Within it, there were thousands of seamounts, unable quite to explode into the sky, and now frozen like pulled taffy at its center was Figure 28, the encounter of Uranus Minor with the Earth. The Earth was in orbit around the electric arc at the time when Uranus Minor passed close by it. Then the Earth's surface was irrotational with respect to the arc, so that one point on the crust, magnetic south, was always leading on the orbit, see the picture, and the point on the opposite side, magnetic north, was always trailing, see overpage. Though the crustal arrangement of that time placed the lands differently, the lands on the present globe which did not take up their present positions until after the catastrophe described here, would be orientated as indicated on figures 28A and B. Relative to the arc and the Sun, Uranus Minor set the Earth on the trailing side and departed on the leading side. Compare with figure 18. Tearing away crust and creating the moon basin where shown. An abysmal plain where the surface of the Earth's mantle appeared scoured of its covering. It was then, and is now, the deepest basin of the Earth's surface. The blow-off was so great that it pulled the great central magnet of the Earth 436 kilometers toward it, making the shortest circle line of the Earth's magnetic field of today pass through the Society Islands. The Earth's center of gravity was pitched 5 kilometers toward the Great Pacific Depression. In this one brief event, the entire original southern hemisphere of the Earth's crust was electrically ejected into the sky. The unbounding of the crustal granite and mantle from the subsurface magma involved a large transfer of energy. If the interbody transaction is translated into thermal terms, the heat would have been perhaps impossible for the Earth to support without vaporizing the biosphere and the globe itself. About 10 to the 32 joules are theoretically required to peel off the surface layer of the Earth entirely. Here, over half the crust was ejected. The balance was loosened and set into motion. However, the transaction consisted of a trade of material for electric charge. Uranus Minor, much more heavily charged, deposited charge upon the Earth. The new electrical energy was incorporated by the molecules of the Earth. Their internal atomic bonds were stretched. A very large amount of energy was required by the chemical bonds and supplied thermally by a huge column or front of lightning bolts blasted a swath into the sky during the pass-by. That heating which occurred was concentrated at the interface of crust and mantle and the bottom of the moon basin. In adjusting its figure following the ejection, the remaining land mass fractured and the Earth expanded by about 20%. Grazia, 1981. This represented a radial expansion of 9% and a corresponding atomic expansion throughout much of the Earth. The remainder of the continental mass that had covered the Earth fractured into the complex ocean ridge and land rift system viewed today, figure 29. The separated blocks were electrically repelled and squeezed apart. They rafted speedily towards the moon basin. Lava welled up from below the fissures and widened them. Thousands of new volcanoes were instantly activated. The constellation of fractures exhibited in the world map of figure 29 probably occurred within a day's time. Grazia, 1981, Manson, chapter 4. Tectonic plate theory today regulates and fractures to a remote, unspecified area, with ocean basins always present. It invokes various mechanisms to accomplish over great stretches of time. Complex, slow movements of a number of plates carrying continental crust. The theory is not only unnecessary, it is mistaken on most obvious criteria. Melvin Cook, 1966, page 189. From the perspective of his research on explosives, points out readily the unified and simultaneous features of the global fracture system, finding in them what is ordinarily to be perceived in an explosive impact upon a globe.
Everyone
Possibly,
left me.
certain Minor fractures branched out or lengthened in the following months or years. Some fractures were not fully consummated, such as the African Near East Rift and the Trans-Asian Rift. Others have been covered in part by subsequent torques of the crust, as in the case of the San Andreas Fault, which was buried in the western movement of North America, or the Red Sea Adriatic Rhine Valley Rift, which was partially overridden by the Alps. It will be noted, too, how the Atlantic Ocean crack probably shot out from an Arctic base, traveled swiftly but against resistance, and then branched off to circumnavigate the South Pacific area, sending 4 continents on their separate journeys: South America, Africa, Australia, and Antarctica. A deluge of water fell from Uranus Minor as it passed. These waters were then replaced. The water carried away with the lost crust, fell into the hot fissures and onto the volcanoes blasted into existence at the passage. There the waters exploded, expediting further cracking of the continents. The world, which shortly before had been heading for an icy end, now became hot and steamy and was threatened by falling water and rock. A cubic kilometer of Earth's atmosphere at present contains 10,000 tons of water. If the Uranian deluges were precipitated by electrical activity of the Earth's electrosphere, see ahead to note B, only 540 tons of water per cubic kilometer would be required in order to achieve the oceanic levels that we estimate occurred in the Uranian lunar periods. In the course of a millennium, an annual rainfall of 1.2 meters depth would have descended upon the Earth's surface, a rainfall that a substantial section of the world's people enjoy today. This would be adequate to fill the basins up to the continental slopes, about half of the present ocean volume. Most of the rest of rainfall belongs to the story of Saturn, Chapter 14, next chapter. Can't wait to get to it. The fractured surface of the Earth, figure 29. Now, I guess what it's saying is that he's going with the theory that the moon was born out of the Pacific Basin. Well, it's entirely possible. There's got to be a reason why there is no land in half the world. All of the land is on the Atlantic side. The whole Pacific Ocean, outside of a couple little islands, is empty and deep, the deepest ocean in the world. So, whether the moon was swiped from Jupiter or created from the Earth, I think it's an interesting story, and you never know what can be gleaned. Following the removal of the moon from the bulk of the Earth by the action of passing Uranus Minor, the surviving broken continental crust of the Earth shattered and rapidly scattered, taking up new positions around the craters surrounding the moon basin, and what is today the Pacific Ocean deep. The troughs, ridges, and faults of the current crust were sculptured as the moon was torn from the Earth and as the Earth recoiled and recovered from that devastating encounter with Uranus Minor. The volcanic and mountainous rim around the Pacific Ocean was created in this same catastrophe. The most prominent astroblims, were also products of the age of Urania, but not all of them were blasts accompanying the ejection of the moon. See, that's where Ramon and de Grazia differ. Ramon says the moon was captured from Jupiter. Both are entirely possible. Yeah, I think the only place that they were the same in is the whole star creating the planet scenario with the cosmic egg. But I always wondered, and I'm sure that probably could have very well happened, but so was the Earth separate from all that? Is that why we witnessed it? We witnessed it? I often wonder that. I mean, it'd be hard. If we were part of all of that going on, then how could we just appear here? We must have been in existence before all this happened. That's the only thing I can think of. Okay, back to the story. Sorry. Areas were set on fire. Elsewhere, newly created basins were being paved with basalt. As floods descended from the highland, they were vaporized on the hot lava. The water recirculated. Torrents of rain fell upon cooler land, producing another flood, which was once more vaporized, and assembled to launch yet another torrent. The sky remained cloudy. The oceans formed. With extra charge on the globe, the Earth's volume increased. The continental blocks fractured and sometimes folded as they conformed to the underlying shape of the Earth's body, and occasionally as they underwent collision. Thus, the geography of the modern world was established. Separated continents, ocean basins, global fractures and ridges, mountainous ramparts around the Pacific Basin, and a global circling welt, the old rotational equator, which forms the other great mountain chain of this planet. The Maharovich discontinuity, which is found beneath the crust throughout the world, marks the level at which the ancient crust was severed from the underlying solid. The continents continue to float, moving today ever so slowly, but only 11,500 years ago, that motion was initiated in hours and rapidly completed. 3,000 years later, the continents were almost at rest and located close to where they are now found. They came to a halt because an electrical equilibrium had been established among them, at both their prows and their sterns. So even land masses have to equilibrate electrically. Interesting. The ocean basins by then held water roughly to the base of the continental shelves. Many seamounts and present oceanic islands. A seamount, I see, okay. That's just what it says it is. A seamountain. Were exposed and acquired biospheres in time. But another deluge, the Saturnian, or Noachian, was to come. The sculpting of the ocean basins occupied a millennium. During all of this time, waters continued to descend onto Earth from the sky in rains and occasional small deluges. Both old and new waters transversed the continental masses in the gorges of the major fractures, converting them into rivers that poured over the continental shelves and into the abysses, forming slopes too. From the large amounts of detritus that they transported, the slopes were largely formed from broad-sheeted runoffs from the continental blocks. Within the basin, the heavy heat from continuous mantle extrusions evaporated the waters, forming dense clouds that filled and rose above the abysses into the atmosphere above the continental blocks. The early continents, until eroded, were large buttes surrounded by the new paved basins located 5,000 meters below the surviving land masses. There are indications that the drop of 5 kilometers into the abyss from the continental shelves was known to the ancients. Uranus, the Greek super Uranus, cast his rebellious sons into Tartarus, a gloomy place in the underworld, which lies as far distant from the earth as the Earth does from the sky. It would take a falling anvil 9 days to reach its bottom. Graves, Hesiod. One notes the gloom, the dense clouds below the habitable plateaus, the position below the human world.
Precipitousness.
Precipitousness, gotta find it. The metaphor of an unimpeded falling object. Ancient sailors spoke of falling off the edge of the world, a fear also present in the modern child. The concept of hell, which John Locke said was so persistent that it must have represented some human experience, may have arisen from the era of the great chasms. Hell is straight down, is burning, is fulminating, is sulphurous. There was, too, a world of the antipodes that could not be reached, possibly across the abyss. Drier. At higher altitudes on the plateau, and where the edges of the abysses were remote, snow fell and glaciers formed. Such appears to be the only scheme by which the heat needed to raise the waters can be supplied. While an area that can support ice caps may exist to receive the waters, the old ice falls had been melted in the lunar eruption. The new ice persisted until the basins were filled up to the continental margins and the ocean cooled. Then, in the golden age of Saturn, the ice melted into the ample basins. Not until the Super Saturn nova was there another ice age. The disposition of the atmosphere is a crucial problem for our model. The atmosphere would have been sucked up under a gravitational model, and unquestionably much atmosphere and also water was lost in the eruption into space. However, the electrosphere was already operative, as indicated earlier, and was ionizing as well as electrically repulsing, and hence returning the gases that sought to leave the Earth. The reduction in atmospheric pressure was short-term and unquestionably fatal in a great many instances. Even at the antipode of the catastrophe, the air would have rushed toward the scene of the disaster. Some help would have been derived from counter-winds electrically repelled and driven to the antipode. The electrosphere, containing a mixture similar to, but richer than, that of the weakened plenum, would have originated downdrafts at the antipode. Assuming that the pre-lunarian atmosphere was 3 times the present density at sea level, and taking as the short-term extreme the habitat of people in the high Andes today. The atmospheric pressure might have been reduced to 1/6 for a short time. This would not eradicate life. The departing Uranus Minor is deflected slightly from its path by the Earth. It then crosses the binary axis so as to approach the Sun on the forward side, orbiting directly. Its passage by the Sun causes an electrical transaction which increases Uranus Minor's negative electric charge and ejects it into an orbit beyond the surviving binary pair. It now becomes the planet we know as Uranus, or possibly the planet Neptune. See ahead to Chapter 14. The granite and mantle material removed in the passage of Uranus Minor past the Earth is strewn along an arc between the retreating intruder and the gashed Earth, there mingling with ejects from Super Uranus And traveling with Uranus Minor, a portion of this debris escapes with Uranus Minor, but most of it, amounting to about 1/50th of the Earth's volume, is left behind in the space near Earth. For a time, some of it fell back upon the Earth as stone and dust. The rest, partly molten, was assembled by electrical pressure into a rapidly cooling globule, the form of fission of the body. In such a manner was foreseen by G. Darwin and Fisher. Later, Baker, 1954, constructed a simple instrument depicting the process. His drawing of the critical stage of the fission is reproduced in Figure 31. Figure 30, fragmentation of Super Uranus. In a scheme from the relocation of Uranus Minor, it is shown after its explosive ejection from the solar companion, which to that moment had been Super Uranus, but then had become the smaller Super Saturn. The released fragment, Uranus Minor, first traveled sunwards along the magnetic tube, where it passed close by the Earth, E, tearing crust away and forming the Moon in the process. Thereafter, the still electron-rich Uranus Minor moved into the vicinity of the Sun, S, before escaping into the outer regions of the system beyond, and the orbit of the new companion, O, where it is likely located today as one or the other of the two most distant major planets. A new sky god, goddess, the Moon, is born. Child of Mother Earth, Aphrodite, Urania. There you go, Rick. She is worshipped after her father retired from Earth's view. Fission of the Earth-Moon pair. This simple diagram illustrates the minuteness of the Moon compared to the Earth's bulk, despite its having removed half the Earth's crust when it departed. Eventually, the Moon orbited the electrical axis, repelled by its excessive charge to a greater distance from the axis than the Earth. From its removal as a piece of the Earth to the present, the Moon can never have been free of the Earth. If it had escaped, it would now be an inner planet of the Sun and an independent orbit, and far from the Earth. This leads us to conclude that so long as the Earth remained in the magnetic tube, the Moon remained close by. It orbited then, as it does now, with the Earth, though considerably closer to the Earth than today, seen only in a daylight sky. The Moon was not a significant object in the sky. Likely it was larger than the disk of Super Saturn, but it was incomparably fainter. It showed no phases, nor could it eclipse any body. It probably was always oppositely positioned in the sky to the arc and at quadrature with both of the brighter stellar bodies. In the period of accretion, debris and lightning would be striking the Moon from the plane of the swath in large part. Far-flung cultures portray the goddess of the Moon as a spinner. The first spinner, de Grazia, 1981, in ancient spinning, as in its modern survivals, threads are held and fed from the one hand to the spindle held by the other hand. Sir, the spindle grows fat and round. Such myths may represent the accretion of the Moon and its assumption of a globular shape. C. Baker, 1954. The process would have been endured for generations and would have been most impressive at first, especially while the Moon was incandescent. Afterwards, it may have been visible only on occasion during electrical discharges. Treshman and Ogiogan quote Midrashim to the effect that the Moon fell was less brilliant, and tiny threads were loosened from her body. Also, some of her parts fell off. The legendary evidence of the rebirth of the moon is discussed elsewhere. Darwin, Bellamy, Baker, and de Grazia. Physical and astronomical evidence is abundant on the manner and recency of the Earth's perturbation and the birth of the moon. Here we cite only salient examples from several scientific disciplines. The moon's overall density approximates the density of the Earth's mantle material, so it is natural that many scientists have suggested some connection between the moon's origin and the Earth's missing crust. The similarity between the chemical composition of the surface rocks of the moon and Earth enhances the believability of this hypothesis, especially with regard to the amount of the noble metals, gold, platinum, nickel, etc. O'Keefe, 1973. That the moon rocks are more impoverished and in the volatile elements, zinc, cadmium, lead, etc., than Earth rocks indicate that the moon material has been subjected to more heating than has Earth material. The moon rocks were formed under reducing conditions. Ferrous iron is common on the moon, while it is rare on the Earth. Where oxidized ferric iron is found, Arnold. If the moon agglomerates electrically in a depleted plenum, all of these differences are explained. The lunar material is heated as it is wrenched off the Earth. In space, it is dispersed into an oxygen-poor dilute gas, where it accretes electrically again, liberating heat. The forming moon is unable to conduct this heat away efficiently, as had the Earth, which accreted in a manner denser and more electrified plenum at an earlier time. The moon's internal structure testifies to the rapidity of its formation. Wood. Despite a high surface heat flow, the moon's interior is relatively cool today, below 1300 Kelvin. The moon seemingly accreted as a conglomerate, like stew chunks in sauce, de Grazia, 1981. Its 65 kilometers of anorthosite crust reveals that it was melted, or better, metamorphosized electrically at the time of its agglomeration. Its over 3 trillion craters of 1 meter or greater in diameter, short, page 48, show that it underwent extremely heavy electrical blasting and debris bombardment after its emplacement. As a result, we are not surprised that some rocks returned to the Earth from the moon show strong and fairly stable remnant magnetization. Despite the weakness of the lunar global magnetic field, if electrical events magnetize the moon rocks, their in situ magnetizations should be quite disorganized, sporadic, and of varied strengths. Several in situ observations testify that the moon's formation was very recent. Lunar samples do not match modern theoretical expectations about primordial planet composition. Wood. The oxygen isotope ratio in lunar samples is identical to that in samples of terrestrial oxygen. Epstein and Taylor. The amount of helium-4, a product of radioactive decay found in the moon's rocks, is exceptionally low. Hyman. Indicative of the moon's youth. Cracked crystalline surface rocks show evidence of shock metamorphism and rapid cooling. Douglas, 1970. The bombardment has been extensive and repeated, while some debris is of recent origin. Using the conventional timescale, recency means about 1/400th of the moon's age, Using our time scale, it means very recently. Grazi, 1901, Baker, 1954, Velikovsky, 1969. The thin lunar atmosphere is accumulating now. Gases trapped when the moon agglomerated are still escaping from the orifices in its surface. Periodic eruptions are reported, notably in the craters Alphonsus and Plato, and within Schroeder's Valley, Menzel, known as our buddy, Wilkins and more. Moonquakes, frequent though weak, may be taken as evident that equilibrium has not yet been attained within the moon and within the Earth-Moon system, within the Earth's atmosphere too. It is presently impossible, however, to distinguish which or how much of these several phenomena are attributable to the throes of the birth or result from more recent encounters between the moon and other planetary bodies and comets. End of chapter. I think that had to be the longest chapter I've ever read. When he writes, he doesn't worry about saving the reader time, does he? He's pretty thorough. Yeah. The next chapter is
indeed.
when the real fun starts.
The next one is a good chapter.
It's called The Golden Age and Nova of Super Saturn.
That's right. That's right.
That'll be coming next.
Well, I mean,
Hope your holidays are going well.
He's got a lot going for him in the way that the natives in South America, with all that 9-mile long wall that they painted, and Ramon breaks it down better than anybody. And, oh, what's that? Oh, a barbaric beat. Hold on a second. All right. Yeah. Anyways, Ramon breaks it down good, what they were saying, because to me, it just looked like a bunch of something a fifth grader would do with a crayon, but it's actually telling a story, and it's about the sack that burst and everything that came out of it. And, there's a lot of evidence for that, but there's also evidence for the other too. So that's why I don't really have a pet theory. I just like to kind of just paint stroke wide brush and get it all in there, and then we can dissect it and give our opinions. That's what makes learning so fun, I think. Sharing opinions with people and learning from them, disagreeing with them, but not taking the disagreement personally. Just say, okay, we disagree. This is, you can try to convince me of your point of view, and as long as you have an open mind to my point of view, And a lot of times I do what Newton did. I reserve hypothesis until I know more. And I just learn as much as I can. Don't really have a certain pet theory or hypothesis. Just embrace them all as scholarly work. That way, let's see, I'm going to go to the live page. That way I think you learn more, You don't just get it from one source, because it becomes stale and rigid if you do it over a certain long period of time. You got to have other sources so that you can compare. Oh, you love the music? Well, thank you, Robert. The background music, what you were saying? Yeah, I do too. I like cool background music. It's part of the thing, Furries love Greg. Top G. Good to meet you, Top G. I'll give you a little.
Top G is innocent.
Top G is innocent. Good to see you, Robert Howe.
Robert Howe.
Robert Howe. What was that one song? Oh yeah, no, that was something different. Never mind. Don's Wages. Rawr! You the man. Donnie is a hardcore fan. I mean, he loves learning. He loves science, the electric universe, and this channel, Shockwave. Warms my heart to see you, brother. I talk too much and I care too much, but I love you. I always will. All right, so let's get back to it, I guess, huh? Nobody's in the chat room. It doesn't look like anybody wants to chat, so I'll wait till someone shows up and play more videos for a little while. We're going to go long tonight. We're going to go deep.
Play some more videos.
There you are.
You didn't look, did you?
Was that a chapter? Yes, it was, Matt. It was Alfred de Grazia and Robert Milton. They wrote the book in '84 called Solaria Binaria. And it's
Yes.
interesting. Yeah, it is an interesting book. And he gives a lot of details and stuff in there you don't get in Worlds in Collision or any of the other books. It's unique to itself, you know. It's a whole
I've never
different
read
way.
it, so
What's that?
I've never read it, so
Well,
I don't know.
I've only read the pages that I've done. I have a whole playlist.
Yep.
I'll link it in the description for anyone who wants to go deep on it. But
Mm-hmm.
I was working on a little something. I'll give you guys a kind of a. Well, wait a minute. I have to do something first. It'll just take a minute. How's it going, Andy?
Yeah, good.
So I saw Eric in the chat, but he didn't make it to Discord. Was he having problems and stuff?
I think he might have missed it once or twice, but I don't know. You'll have to contact him later and find out where he's having trouble.
Yeah, because he's trying to do it on his phone. I guess his computer fried on him.
Yeah,
And whenever you're trying to do that, I mean, trying to work with an itty bitty little phone. I don't know how you guys do it. I just don't know.
Well,
My
what
son
you do
does
is
it. I don't know how he does it.
you have Discord in your phone,
Uh-huh.
connect into Discord, and then you reconnect to YouTube. So in between, when the videos are playing, you listen to YouTube,
Yeah.
right? And then like, so then I heard you say, "Oh, is anyone in the chat?"
Yeah.
And then I stop YouTube, go to Discord, and answer. So if you parked yourself in Discord and you mute yourself, you can still listen to YouTube. Yeah, and then when you're talking, you've got to turn YouTube off on the phone because otherwise, of course, the volume would it could back through and back feed, and then no one can understand anything.
Yeah, I know. It's like that when I'm lagging too. A couple of times it was really tough.
Yep.
Because
Yes.
what happens is when it's buffering, you can't. It'll skip to when the next time it gets picked up, and it's stopping and starting and stuttering and all that crazy shit.
Yep. So I was going to ask, did most of the people in the chat, were they able to watch?
What's that?
I was wondering if most people that are in the chat were able to watch during the week when you did the video with
the Wall Thornhill with Neil.
Yes, yeah. Just wondering if they were able to. You re-released that too, didn't you, Greg?
I did. I released the actual 1 hour show on uploads, and then I just left the live stream. I proof watched it once, and there wasn't anything in there that was too bad. So I thought I thought it was going to be worse than it was.
Yep.
You know what I mean?
That was a good couple of hours. It sort of went real quick, didn't it?
It sure did, yeah. And I had a really good time. And Neil, man, he's always so knowledgeable. Him and Shockwave both. They're just so knowledgeable about the electric universe. It's a joy to have him on because I learn. It blows my mind actually.
And like you just said before, I'm not fixed on any one theory.
Right.
And really that's the beauty of it, is if you don't have a closed mind, you put it together and you go, gee, that sounds like when Neil was talking about the moon, how the moon was possibly a planet in its own right,
Mm-hmm.
and Earth and moon got too close together and then started basically orbiting each other, orbiting the sun. That's how he described it, wasn't it, Greg?
Yeah, and he's what's the word I'm looking for? He gets his. articulate. That's the word.
Hmm.
He's articulate. Yeah.
Yeah, yeah. Now, it's
Yeah.
good from time to time to have different people and a bit of an open discussion, and you never know what comes out of it.
Right. Right. Yeah. You never know. Yeah. But Neil's always interesting. Everybody we talk to is cool to talk to. You know.
Yeah.
Yeah. We don't.
Yep.
We don't really have. I'm probably the most boring guy on the show, so that's pretty good. You know.
Oh, I like that one.
I'm trying
Yeah,
to set up some images because I'm gonna play an acetate.
Okay.
It's a rough version of a video I'm gonna be doing, and I'm working on it here and there. I just started, so
Yep.
uh, I'm lining the pictures up right now as we speak to just kind of show along with what I'm saying.
Yes.
It's not going to be. It's not complete by any means, but it's just a little taste of something different. You know, a lot of things in the world interest me. I love the electric universe and Saturn theory, but man does not live on electric universe and Saturn theory alone. We have to have other things like news and history and stuff like that. You know, and certain events that happen in history catch my attention and intrigue. You know what I'm saying?
Yeah, like I say, it's good to be able to. Well, we're in a lucky position. When you look at it, we are able to have that more open thought process, and that because there is a lot of different things you can access
Yeah.
to read, listen to, all that.
Mm-hmm. Yeah, there's just so much. There's just so much, and you look at all the mystery in the world from, the ancients. I mean, it's just one mystery after another. There's really not much that makes sense. Outside of there had to be some really smart people on Earth at one time. But this story is it's about a boat that sunk when I was in high school here on the Great Lakes, and it always captured my fascination. Not the fact that 29 people died, but it was the ship that was supposed to be indestructible. You know, when the whole Titanic thing, they say it's unsinkable, and it sinks. You don't ever say that about your boat. But this boat was the song. It inspired the song, which I'm actually learning right now. Wreck of the Edmund Fitzgerald. You're familiar with it, right, Andy?
Yeah, I am. Yes, I am.
And it's a great story. So I've just got about maybe 10 minutes started of it. I'm just going to play it.
And it's also interesting. It's also interesting, Matt, thinking of the.
Oh, it is. Yeah, it's 500. It lays in
But
500. Go ahead.
Yeah, but they still really don't know
No.
exactly what caused it, whether it got between two big waves and
Yeah.
snapped in the middle,
It
or whether
disappeared.
it
It
or
disappeared.
whether it hit, or whether it hit rocks that opened the bottom of it up
Yes.
and let a huge amount. But it went down. But when it went down really quick.
Like the
Yeah.
captain of the Anderson, which was following him, said he took a nosedive. That much is pretty much certain. Just what caused him to take it, that's the big
No one-
intrigue. A lot of
That's
people
right.
have their
Well,
theories. Well, anyways, this is what I have so far.
Well, before you do that, one thing in the chat.
Yeah.
Invisible died. Anyway, what's your thoughts on Planet 9X and its possible inhabitants?
Planet X?
Planet X.
You mean
yeah,
like
9X.
Nibiru? Well, that's classic thing. Nibiru was probably real, but it was Saturn. That's Saturn theory. That's what happened. The planet came in with two satellites and crashed into maybe the sun or Jupiter or whatever. There was an exploded planet where the asteroid belt is. So there was chaos going on in the solar system at one time. And that's the whole thing that we're trying to say. That whole Nibiru thing is Nibiru, but it was Saturn. It was a ground dwarf with two planets that had life on them, Mars and Earth. But it was nocturnal life at one time until it came into the solar system. And that's how do human beings get to Earth? That's the big $64 million question. But we can get back to that. That's always interesting to me, to talk
And
about.
then see if Kronos made mention. While Thornhill turned me on to the electric universe.
Yeah. Oh,
Yeah, well, I think you'd also agree,
you
Greg.
and
He
10
did
million
with
up. Yeah.
yes,
Yeah,
and he was very good at articulating it, especially with Don Scott and who else
probably
was there? With
one of the best. One of the best ever.
Yep,
Yeah.
yep.
Yeah. He took Velikovsky's work to the next level.
I'd agree with that. Yes.
Yeah. I think so. Yeah.
I think
He
Sat-
really
Sapphire-
gave Velikovsky his props.
Yeah.
No other person has done that. They rip them off and claim it as their own, which is what irritates the shit out of me.
Yep.
That's what I mean. There I go caring again. Why do I care so much? I shouldn't, but I do.
Well, it's just thought,
Yeah.
isn't it?
Yes.
Anyway,
All right. Let's get on. Let's get on this little Edmund Fitzgerald. It's about 10 minutes. All right. Here we go.
All right. Catch up.
All right. Wreck of the Edmund Fitzgerald. The SS Edmund Fitzgerald was an American Great Lakes freighter that sank in Lake Superior during a storm on November 10, 1975, with the loss of the entire crew of 29 men. When launched on June 7, 1958, she was the largest ship on North America's Great Lakes, and she remains the largest ship to have sunk there. She was located in deep water on November 14, 1975, by U.S. Navy aircraft detecting magnetic anomalies, and found soon afterwards to be in two large pieces. For 17 years, the Edmund Fitzgerald carried taconite iron ore from mines near Duluth, Minnesota, to ironworks in Detroit, Michigan, and Toledo, Ohio, and other Great Lakes ports. As a workhorse, she set seasonal haul records 6 times, often breaking her own record. Captain Peter Pulser was known for piping music day or night over the ship's intercom while passing through the St. Clair and Detroit rivers, between Lakes Huron and Erie, and entertaining spectators at the Sioux Locks between Lakes Superior and Huron, with a running commentary about the ship, her size, record-breaking performance, and the DJ captain endeared Edmund Fitzgerald to boat watchers. Carrying a full cargo of ore pellets with Captain Ernest M. McSorley in command, she embarked on her ill-fated voyage from Superior, Wisconsin, near Duluth, on the afternoon of November 9, 1975, en route to a steel mill near Detroit. The Edmund Fitzgerald joined a second taconite freighter, the SS Arthur M. Anderson, by the next day. The two ships were caught in a severe storm on Lake Superior, with near hurricane-force winds and waves up to 35 feet, 11 meters high. Shortly after 7:10 p.m., Edmund Fitzgerald suddenly sank in Canadian waters, 530 feet, 15 nautical miles from Whitefish Bay, near the twin cities of Sault Ste. Marie, Michigan, and Sault Ste. Marie, Ontario, a distance Edmund Fitzgerald could have covered in just over an hour at her top speed. The Edmund Fitzgerald previously reported being in significant difficulty to Arthur M. Anderson. I have a bad list to starboard, lost both radars, and am taking heavy seas over the deck. Yeah, it's fenced down too. One of the worst seas I've ever been in. However, no distress signals were sent before she sank. Captain McSorley's last message to the Anderson was, "We're holding our own," at 7:10 p.m. Her crew of 29 perished. No bodies were recovered. The exact cause of the sinking remains unknown, though many books, studies, and expeditions have examined it. The Edmund Fitzgerald may have been swamped, suffered structural failure, or topside damage, grounded on a shoal, or suffered from a combination of these. He passed a little too close, the captain of the Anderson thought, to Caribou Island, where they have this thing called 6 Fathom Shoals. His map was off by a mile, so the captain of the Anderson feared that he had run aground and ripped open his bottom. The disaster is one of the best known in history of the Great Lakes shipping. Gordon Lightfoot made it the subject of his 1976 hit song, Wreck of the Edmund Fitzgerald, after reading an article, "The Cruelest Month in November." the coolest month in the November 24th, 1975 issue of Newsweek. The sinking led to changes in the Great Lakes shipping regulations and practices that included mandatory survival suits, depth finders, positioning systems, increased freeboard, and more frequent inspection of vessels. Edmund Fitzgerald left Superior, Wisconsin at 2:15 p.m. on the afternoon of November 9, 1975, under the command of Captain Ernest McSorley. She was en route to a steel mill on Zug Island, near Detroit, Michigan, with a cargo of 26,116 long tons of taconite ore pellet. It soon reached her full speed of 16.3 miles per hour. Around 5 p.m., Edmund Fitzgerald joined a second freighter under the command of Captain Jesse B. Bernie Cooper, Arthur M. Anderson, destined for Gary, Indiana, out of Two Harbors, Minnesota. The weather forecast was not unusual for November, and the National Weather Service predicted that a storm would pass just south of Lake Superior by 7 a.m. on November the 10th. The SS Wilfred Sykes loaded opposite Edmund Fitzgerald at the Burlington Northern Dock No. 1 and departed at 4:15 p.m., about 2 hours after Edmund Fitzgerald. In contrast to the NWS forecast, National Weather Service forecast, Captain Dudley Paquette of the Wilfred Sykes predicted that a major storm would directly cross Lake Superior. From the outset, he chose a route that took advantage of the protection offered by the lake's north shore to avoid the worst effects of the storm. The crew of the Wilfred Sykes followed the radio conversations between the Edmund Fitzgerald and Arthur Anderson during the first part of their trip, and overheard their captains deciding to take the regular Lake Carriers Association downbound route. National Weather Service altered its forecast at 7 p.m., issuing gale warnings for the whole of Lake Superior. Arthur M. Anderson and Edmund Fitzgerald altered course northward, seeking shelter along the Ontario shore, where they encountered a winter storm at 1 o'clock a.m. on November 10th. Edmund Fitzgerald reported winds of 52 knots, 96 kilometers, 60 miles per hour, and waves 10 feet high. Captain Paquette of Wilfred Sykes reported that after 1 a.m., he overheard McSorley say that he had reduced the ship's speed because of rough conditions. Paquette said he was stunned to later hear McSorley, who was not known for turning aside or slowing down, state, "We're going to try for some lee from Isle Royale. You're walking away from us anyway. I can't stay with you." At 2 a.m. on November 10th, the NWS upgraded its warnings from gale to storm, forecasting winds of 35 to 50 knots, that is, 40 to 58 miles per hour. Until then, Edmund Fitzgerald had followed the Anderson, which was traveling at a constant 14.6 miles per hour. But the faster Fitzgerald pulled ahead of it at about 3 a.m. As the storm passed over the ships, they experienced shifting winds, with wind speeds temporarily dropping as wind direction changed from the northeast to the south and then northwest. After 1:50 p.m., when the Arthur Anderson logged winds of 50 knots, 58 miles per hour, wind speeds again picked up rapidly, and it began to snow at 2:45 p.m., reducing visibility. Arthur M. Anderson lost sight of the Edmund Fitzgerald, which was about 16 miles ahead at the time. Shortly after 3:30 p.m., Captain McSorley radioed Arthur M. Anderson to report that the Edmund Fitzgerald was taking on water and had lost 2 vent covers and a fence railing. The vessel had also developed a list to starboard. For landlubbers, starboard is short for steering board, which was usually always on the right when boats were first made. So then to port would be left, because that's where you would port up to the dock. 2 Edmund Fitzgerald's 6 bilge pumps ran continuously to discharge shipped water. McSorley said that he would slow his ship down so the Arthur M. Anderson could close the gap between them. In a broadcast shortly afterward, the United States Coast Guard warned all shipping that the Sulaks had been closed and they would seek safe anchorage. Shortly after 4:10 p.m., warned all shipping that the Sulaks had been closed and they should seek safe anchorage. Shortly after 4:10 p.m., McSorley called Arthur M. Anderson again to report a radar failure and asked the Anderson to keep track of it. Edmund Fitzgerald was effectively blind, slowed to let the Anderson come within a 10-mile range so he could receive radar guidance from the other ship. For a time, Arthur M. Anderson directed Edmund Fitzgerald toward the relative safety of Whitefish Bay. Then at 4:39 p.m., McSorley contacted the U.S. Coast Guard station in Grand Marias, Michigan, to inquire whether the Whitefish Point light and navigation beacon were operational. The U.S. Coast Guard replied that their monitoring equipment indicated that both instruments were inactive. McSorley then hailed any ships that lost power in Whitefish Point area to report the state of the navigational aids, receiving an answer from Captain Cedric Woodward of Avafors between 5 and 5:30 p.m. that Whitefish Point light was on, but not the radio beacon. Woodward testified to the Marine Board that he overheard McSorley say, "Don't allow nobody on deck," as well as something about a vent that Woodward could not understand. Sometime later, McSorley told Woodward, "I have a bad list. I have lost both radars and am taking heavy seas over the deck, in one of the worst seas I have ever been in." By late in that afternoon of November 10th, he sustained winds of over 50 knots and were recorded by ships and observation points across eastern Lake Superior. Arthur M. Anderson logged sustained winds as high as 58 knots, 67 miles per hour, at 4:52 p.m., while waves increased to as high as 25 feet by 6 p.m. The Arthur M. Anderson was also struck by 70 to 75 knot gusts and rogue waves as high as 35 feet. At approximately 7:10 p.m., when Arthur M. Anderson notified Edmund Fitzgerald of an upbound ship and asked how she was doing, McSorley reported, "We are holding our own." She was never heard from again. No distress signal was received, and 10 minutes later, Arthur M. Anderson lost the ability either to reach the Fitzgerald by radio or detect her on radar. Northwestern Mutual Life Insurance Company of Milwaukee, Wisconsin, invested in the iron and minerals industry on a large-scale basis, including the construction of the Edmund Fitzgerald, which represented the first such investment by any American life insurance company. In 1957, they contracted Great Lakes Engineering Works, nicknamed GLUE, of River Rouge, Michigan, to design and construct the ship within a foot of the maximum length allowed for passage through the soon-to-be-completed St. Lawrence Seaway. The ship's value at the time was $7 million, equivalent to $52.4 million in 2021. Edmund Fitzgerald was the first Laker built to the maximum St. Lawrence Seaway size, which was 730 feet long, 75 foot wide, with a 25-foot draft. The molded depth, roughly speaking, the vertical height of the hull, was 39 feet. The hold depth inside the inside height of the cargo hold was 33 feet 4 inches. GLUE laid the first keel plate on August 7th that year. With a deadweight capacity of 26,000 long tons and 729-foot hull, Edmund Fitzgerald was the longest ship on the Great Lakes, earning her the title Queen of the Lakes. Until September 17, 1959, when the 730-foot SS Murray Bay was launched. Edmund Fitzgerald's 3 central cargo holds were loaded through 21 watertight cargo hatches. And they had to be fastened. There were little clamps. They had to be dogged down. They had to be tightened with a certain tool. And one of the reasons why they think she might have sunk was they weren't properly closed for a storm, because sometimes they would skip some or not tighten them down. It was hard work to do that. But a lot of people tend to side with the crew, saying that there's no way they wouldn't have had them dogged down. But when they dove it, they found ones that weren't. And they could tell the ones that broke, they could tell the ones that were broke from the ones that were left undone. So I don't really know what to make of that. Carrying on. And that's it. And that's all I have. I didn't know my mic was on. Shit. But what do you think there, Andy? Not bad, huh?
Good. See, Renegade in the chat.
Yeah.
Had some comments on. I don't know.
I was hoping that some folks that reside in Canada might know a little bit more about it. So
Yeah.
Renegade knows something.
Yeah, Renegade had a bit here about lake effect. Squalls are insane. And
Time before everything came from China, absolutely.
yep.
And Algoma Steel. Shout out to the Sault Sault Ste. Marie. My daughter was born there. Oh, that's cool, man. Lake effect squalls are insane. Well, what they had was three, like they had a nor'easter and then something else. There was like three storms converged right over the middle of the state. Could you gently? Yeah, I'm sorry, dude. I'm so freaking retarded. Half the time I think I got my mic on and it's off, and half the time I think it's on, off, it's on. I'm sorry, that blows it. I know.
It wasn't too bad,
I'm
Greg.
noisy.
It wasn't too bad.
It's noisy here.
Those gentle fingers weren't felting the keys too bad.
No, I know. Yeah, that's right. Yeah, because I was trying to make it easier visually for you. I didn't know the damn mic was on. You see, always got to screw it up somehow.
Yep. So
Shit.
I can't imagine
That
the
ruins
size
that.
of those plates.
What?
I can't imagine the. Oh, no, it wasn't too bad. I
You're
can't
just
imagine
being
the
nice.
size of those Great Lakes because they must be as big an area as some.
Well,
Ocean.
what's cool is like,
No?
yes, the Lake Superior is the biggest of them all. And let me show you something here that I learned. Been watching a few videos, researching it, and well, if you see the map right here, there's a little island called Caribou Island. And just north of that island is 6 Fathom Shoal, and Edmund Fitzgerald was going blind. He was sailing blind, and the Anderson was doing radar for him. But the Anderson had a different path he took because this guy wanted to get closer, and his map was off by a mile. So they think that he ran aground and shredded his hull up. But the wreck, it ended up upside down in the back. Let me see. Let's see. Edmund Fitzgerald on Lake Bottom. The big controversy is there it is. The Coast Guard did their little, whatever they do, examination, and they came out and said that the cargo hold wasn't fastened good enough, and the ship got too heavy with water. He had two pumps. They were pumping out 800 gallons a minute, and it still couldn't keep up with the water coming in. So he had to have run aground or something, because I don't think water could get in. Even like if the hatches were like leaky, how much water could they really? I mean, this sounds like it was massively coming in. Because what happened is they got hit with two giant waves, and it pushed his bow down, because the Anderson experienced them about an hour earlier, and he thinks that them two waves hit it, drove the nose down, and it was too heavy to bounce back. It didn't have enough buoyancy, and it just plowed right into the floor, because it was longer than it was deep. It was 540 feet deep, and the ship is 729 feet long. And that's how it came to rest. Now you notice the hull on the back isn't disturbed, but if he would have hit it in his bow, he probably would have steered hard, to port or something. So I don't know. It's interesting. The first mate lost his captainship because he ran a boat aground, and some feel that he was at the helm when they were going past 6 Fathom Shoal. This is what I've gathered from watching a few videos and reading. And the Anderson guy, Bernie, they went back out there and searched the whole next day in the storm, and couldn't find him. They just sunk, just 10 seconds, boom, gone.
So a day or so later, when they started finding some of the remnants, stuff that was in the ship washing up on shores.
Yeah, they did.
They realised it was gone.
Yeah,
and then
some
they
of
realised what it is.
But they say Superior never gives up her dead because it's a very cold lake. The body is refrigerated and it can't expand. Bacteria makes the body expand, but it has to be warm enough. So those bodies are like being kept in permanent, like 20 degrees.
Preservation. Yeah, so they're preserved.
Yeah.
Well, I liked how then they resurrected the bell. What was that? They went down and got the bell.
Yeah, they
that
did.
Was what, the early 1990s, around there.
1995. Yes, there's an excellent documentary on it. I'll put it in the description. A lot of people were miffed that they cleaned it up. They wanted them to leave it like it was, all tarnished. And they cleaned it up and replaced it with a memorial.
Mm-hmm.
Yeah, that was a good documentary, wasn't it? I thought.
Yeah, that was good.
And there's another one that was made in the 80s that's really good too. It's old school.
Yeah.
Yeah, that everything, all sunken ships have intrigued me. The Titanic and the Bismarck, and all those famous ones.
Yeah, well, you look, you read history and that, you see history, and you think, gee, some of these places, like, say, between Britain and France, wow, what's on the bottom down there must be unbelievable. The amount of ships over the centuries. And that ended up on the bottom, and then they'd have battles, and they'd end up blowing each other up and sinking each other as well.
Yes.
And when you look up around the top of Scotland, it gets very, very rough up there in that North Sea, and around the tip of Cape Horn, is it? Yeah. And there's some fairly rough.
There's 6,000 sunken ships in the Great Lakes alone, so just imagine what the ocean's like.
Yes.
It's probably 60,000 or more.
That's amazing, isn't it, when you think about it, 6,000.
Yeah. If you look at Lake Superior, what the boaters or the sailors will say is it looks like a wolf's head. There's the Isle Royale where the Roman sword was found. And I don't know. No, that's not the one with the money pit. But it looks like there's its nose and then there's its mouth, It looks like a wolf. And it's cold all year round. You can't go swimming in it. It's too freezing. Even in August.
I like that, Cronus, yeah. Bottom of the English Channel is a scrapyard. I like that.
That loch in Scotland too, Loch Ness, that's always cold too. I bet it doesn't give up its dead either.
Probably true there.
Yeah.
Mm-hmm. But I watched one going back, it would have been, time flies, it'd have to be probably 8 months ago now.
Mm-hmm.
And it was on the last of the big ships, the big sail ships. And they used to run them from Adelaide in Australia to England, carrying grain. And they go down along the Southern Ocean, and they were talking where you had the deck about 6 feet out of the water. And a lot of the time going through there, all that just had water going over it, and how they stayed afloat. And those people that sailed them, the sailors and that on them, they were just in constant, they could have days where they were just in constant rain, wind and water. Yeah, and they were getting up to speeds of 65 knots. So that wasn't bad.
Not at all.
And then World War II put a fair stop to it. And then there was one more done where they'd do their race. So they used to leave Adelaide, race to England, see who could get there first. That was the idea, because the way I understood it is the first one there got to sell the car, offload their cargo and maybe get the best rate for it. Yeah. No. And that was a fair time on sea too. That was a fairly long voyage for those ships. Yeah, so it's
So where you live now, in the water there, or the ocean, I don't know if I'd want to go swimming. That's where great white sharks reside. Those things are just unbelievable.
not everywhere, only in certain areas.
Yeah, like the barrier reef.
No, I don't think great whites are there. I
But-
think the great whites, from what I understand, the great whites are more from on your Western Australian coast, Perth down around the southern and across to the Gulf in South Australia. And there seems to be a current flow there where there's good feeding, and they tend to move up and down in there most of the time.
Yeah.
So, but that's pretty rough old water too to go swimming in out, at any real depth.
They live up to
'cause
80 years. Did you know that?
Yeah, that'd be right.
Yeah, that's a long time for a sea animal. Same
Well,
thing.
dolphins live good ages.
Mm-hmm.
Dolphins, the old turtles.
Oh, those turtles, they live to be like 150.
Although I think they'd be battling now in a lot of open seas because of those big fishing factories. They just take everything, don't discriminate.
Maybe it's tortoises. Man, I would imagine it should be turtles
Tortoise,
too.
that might be the word. Yeah, that'd be the right word for it, a tortoise.
Yeah, because tortoises are on the ground, right? And then turtles are in the sea.
Yeah.
I imagine
One
they're
or the other.
related somehow. Certain species of them must have said, I don't want to be in the damn water.
Yeah,
That's interesting how
Yeah.
that happens,
yeah. And they carry their home on their back.
Right.
That'd be a heavy slog, wouldn't it?
Yes.
Yeah, carrying your house with you.
The bottom of
So-
the English Channel is a scrapyard. It says Sea of
Yeah.
Kronos, yeah. I could see a
Yeah.
yeah.
So,
Right into the ground, yes, that's right. That's right, Rick. It just came up, it went down, and it just kept going. Bang! Hit the floor at 30 miles an hour, they estimate. Because the last word he said was, we're holding our own. That was a 710. And then he was gone. Just like that. Big 730-foot steamer,
yeah, well, where Sea of Kronos speaks about the munitions, weapons, vehicles, and everything dumped in the sea around the UK.
Yeah,
Well, that happened in the Pacific too after World War II, didn't it, Greg?
yeah.
They dumped all the so much of the equipment that was used with the fighting the Japanese
Mm-hmm.
in the ocean because they didn't want it being repurposed for other uses, as they considered it would stop a lot of their economic activity in the building of equipment, trucks and things. So that happened there too.
After the Marines took Okinawa, which was the bloodiest battle of the campaign, and after they took that island, they had started amassing a landing force. They were going to have a D-Day type landing on Japan. And they had this huge, cannons and tanks and this whole big old arsenal prepared. They were going to land 800,000 people or something like that. It was going to be the biggest landing in history, and the atom bombs canceled it. But Fletcher Prouty, who was a liaison for the CIA as later on in life, was a pilot that was engaged in that stuff, bringing it there and making sure it gets there. So he asked the harbor master, what are you going to do with all this stuff? Send it back to the States? The guy said, oh no, it's not going back there. Half of it's going to South Korea, and the other half is going to Vietnam. Well, it just so happens that our next two wars were Korea and Vietnam. Isn't that funny how that works out?
That's interesting, isn't it?
Yeah.
Yeah, they were getting pre-planned.
Somebody had already
Yep.
made that call.
Yeah.
And that's what's
Yes.
so intriguing about American politics from the end of World War II to, like, say, Reagan. It, kind of stops there for me. But that whole part, all the intrigue and freaking string pulling that was going on, just dirty deeds done dirt cheap, man. And these are people we should be looking up to, setting an example, you know. It's just ridiculous.
Yeah, well, I see last week whereby Jimmy Carter has gone into, a nursing home type situation for permanent care. I think he's got a bit of dementia maybe. But he's well in his 90s.
Yes.
I thought he died a few years ago, but
No.
no. And there was a big change when Reagan came in. That 80s period really created big change, didn't it?
Yes, it did.
Yeah. So.
Yeah, and well, just after the Reagan period, because everything was booming when Reagan was president, is he copied Kennedy's tax cuts and reapplied them. But what happened is the economy was booming, and then we get Clinton in, and he starts signing NAFTA, slash to the U.S. Manufacturing, and then he signs a deal with the Chinese. All of a sudden, our departments are folding up and going to China. We're the ones who built them to the country they are today by letting them have all our jobs.
Yeah.
But
the big thing that
Reagan,
the big thing Reagan did that created all that activity was, remember he bought all that debt off of all the companies. He allowed them to write that debt off that year.
Yeah.
And then there was the furor over, well, you borrowed all this money to do that. It's gonna all the which it did work, whereby it got everything going again because it freed up all that capital through getting rid of the debt. But today, if they did it, they'd just pay themselves bigger bonuses. And
yeah.
It's a different world today.
In the 90s, they coined the phrase downsizing. That all of a sudden came into vogue. But really what they were doing was slashing our jobs. I was working at the time, and I saw it. I saw it happen. And first thing that Ford did was they created a different division called Visteon. It was going to be their parts division. Then all of a sudden, they're starting to inch away from them a little bit. I knew this is the death knell. Well, I was grandfathered in. They couldn't do anything to me, but I wonder now for new hires in the car making industry. All our stuff is made in other countries now. They might as well just build the cars there. It's gotten so stupid that foreign cars, like Japanese cars, are built in America, and American cars are built in Mexico and Canada and China. Go figure. So now they used to say, "Be American, buy American," or I buy what you build. And I had a Ford every year. But now it's you're probably more patriotic buying a Toyota. There's a Toyota plant somewhere. Ford, the only thing they do now at the Rouge plant is put cars together. They're completely out of the parts business now. We used to be number one in manufacturing in the world.
Yeah.
I don't even know what we are now. It's just sad. It should have never happened. There's a thing for companies should have public responsibility. They should be forced to adhere to that. This is the place where you make your money. So this needs to be the place where you sell your goods. Or make your goods, I should say. But Americans are spoiled, and they want too much money, and they want breaks, and they want this. I understand that, but you're the one who created it.
I'm just amazed at how big the car industry is.
Oh, I know.
When you look at it, you see that many vehicles getting around, and they seem to get turned over pretty much 20 years is the life of a vehicle at the max.
Yeah.
And then everything that goes into then just stripping the old one, and there's always new ones. So when you think, geez, there must be a hell of a lot of human hours taken up by the car industry. Yeah, and of course the governments have learned how to tax it well,
Yeah.
so so we get bled by it as well. But yeah, no, the car industry, that mobile industry, that's huge, isn't it? Transport and distribution.
I think America was built pretty much on the automobile, the Industrial Revolution. If you wouldn't have had cars to go from here to there and make it easy, where you'd have to used to hitch up the team and go to town, now you can just go across the street, and go to 7-Eleven.
It really started to make the world a smaller place. Then of course the shipping got faster.
Right.
Again, the world became a smaller place.
Yes.
And then, flight, modern jet planes and that, it's made the world seem really small.
Yes. Indeed.
So anyway.
I agree. Yeah.
So what have you got left to do today?
Well,
this morning, Greg.
Where do you guys feel like going? You want to stay with Solaria Binaria? You want to go in a different direction? What do you guys want to do? I'll do whatever you want. If you guys had enough, turn in, call it a show, or do you want to keep going for a little longer? I'm doing the marathon tonight. I committed to it. So
committed to a marathon.
But I've already been going for. Let's take a look here.
I suppose we just continue on, eh?
5 hours and 45 minutes, 23 seconds.
You going to pull the pin at 6 and restart, or are you just going to keep going?
Well, I was maybe going to hang in there till morning. Maybe Adusa get up, we could have a chat, but we could always go off and come back on.
Well, if you want to do that, because you can't edit it either after you've been 6 hours, can you?
See if Kronos wants Solaria Binaria. Okay, yeah, that's right. Well, let's play the rest of this, and this is a good chapter, actually. This is, no, that's the live stream. This is Saturn. It's the golden age and nova of Super Saturn, and it's only 42 minutes. We've gotten past the two biggies, two or three biggies. So let's hear it. Let's check it out.
No worries. There you are.
Okay.
See you, Kronos. We'll see what we can do.
Okay.
Catch you later, Greg.
Thanks. Bye, Andy. I'm going to turn my mic off right now. I apologize for that. I feel terrible about it.
Chapter 14, Golden Age and Nova of Super Saturn. The great god Saturn, identified by many names of many cultures, and often associated with the planet, which has been known in the most ancient times by that name, is the son of a god. In the ancient Buddhist liturgy, he is called Ravasuda, or son of the sun. Uranus, by his many names, does not have a father, but he is often referred to as the father of Saturn. Uranus is killed, castrated, defeated, retired, or dismissed, and usually It is the work of a Saturn figure. The physical circumstances of his end are those that may be associated with a stellar nova. As we have described it, so, too, Saturn comes to his end in a disastrous struggle thousands of years later, in favor of a new planetary god, Jupiter, also called by many names, and usually made the son of Saturn. There is reason to believe that the ancients, when they used the metaphor father-son, refer to sky bodies, meant the most direct and close relationship of one body to another. Saturn came into his own as king of the gods in the period following the destruction of Super Uranus and the ejection of the moon. We have recited only a portion of the mythic evidence for the period immediately following the rise of the moon god or goddess. There is little coherent knowledge of human societies of the time.
I just thought of something.
Thousands of years
Hold
are
on.
required for the...
I just thought of something. I got to keep it under 6 hours. I can't edit, and I don't know. I might have ruined that whole thing on the Edmund Fitzgerald. It's going to be a video very soon when I get done with it. But right now, it was just a little first draft that I read part of. I plan on getting more in detail, so I'm going to have to end this live stream because if I go over 6 hours, I won't be able to edit. And if it's crappy, it's got to come out. So let's end this. I'm going to start another one right away and finish the story. So look for it. It'll be there. All right? I'm sorry. Got to do it. Bye.
Okay, see you soon, Greg.
Oh, no, you can just stay right here. I'm just going to do it right